Welcome everyone to this brief Python quick start for young coders. This is Dr. Eric Chow. I'm an adjunct instructor at Louis University, IEEE senior member. Today, I would like to present this course, Brief Python. It will help students of the younger coders, such as from 6th grade to high school, 9th grade, for a quick start in coding. And Python is a good language for doing that because Python's syntax is easier than other language. But advanced Python can be very difficult. And we try to minimize the difficulty so that student of this middle school age is able to handle this course and be able to start their coding journey. So first thing I would like to introduce is that with this course, I also have a companion course site called moodle.eco24.com. And I suggest people who would like to get a student account to email me, and I can actually create an account for them. And then if you want to contact us, there are two ways you can contact us. Number one is you use the Facebook Messenger, and the address is facebook.com/dr as Dr. Eric Chow. And you can also reach me at the email echow510. 510 is my zip code. It's Fremont, California. So echow510@gmail.com. And we also provide other high school or computer science courses such as AP Computer Science A, AP Computer Science B, Python, C, C++ to support students' computer activity in high school. Okay, here is a short introduction for myself. My name is Eric Chow, and I'm currently a IEEE senior member and Computer Teacher Association member. And I graduated from the Computer Science and Engineering Department of the National Taiwan University in Taipei, Taiwan. And after that, I actually went to USC for my master and PhD degree in electrical engineering and computer science, and focus on AI chip design, and also for the neural network and optimization problems. And currently, I'm an adjunct faculty at Louis University, located nearby Chicago. And I also participate in many IEEE activities. So let's get started for the course contents. Welcome to this brief Python course, the first Python course for beginners. Chapter 1, Basic Data Types and Operations. My name is Eric Chow, Dr. Eric Chow. Let's get started. So this chapter, our focus is on the Python installation and our course environments and the course resources that you can use, and also teach you how to use Python idle, and then get started with some basic Pythons. So Python language is a general purpose high-level programming language, and it is an open source language. And it was released under a GPL compatible license. And you can download the Python interpreter from the internet free. These chapters will help you to learn Python 3 step by step. And we divided the course into 4 chapters just to suit the need for the middle school students. So it is a basic course. So after this course, we still have Python 1, 2, 3, several other Python courses. And you can also start the high school pre-AP Java and the AP Computer Science A, AP Computer Science P, and some other more courses. So this a brief Python course is intended for the beginners in the middle school. So it is not going to be too difficult. So first thing is the installation of the software. So basically, Python you can actually download from www.python.org. Okay, Python is the #1 language for data science and AI, so it's very popular and very useful language. And Python is the most rapidly growing open source programming language. So it's free, but the installation can be some effort, but you need to get used to it, and then it will be very easy to use. Okay, so first thing is that you need to go to this website called www.python.org. Okay, and let me show you by the browsing the internet. So basically, you bring up your browser, and then you go type www.python.org. Okay, and you will come to this website. You can click on download and download this one. That's okay. And you can also go to let's assume that you are using the Windows. So you click Windows, and there are several versions. And usually you pick the newest version. And then, for example, mine can be this one, Windows 64. I'm sorry, a 64-bit. This one. Okay, sorry. So you pick the right installer for yourself. So my computer is the Windows 64-bit installer. So this one. Okay, yours can be different depending on your OS. So once you click it, you can start to download and install. But here, I already installed, so I am not going to repeat the installation effort. But I will show you what are the important parameters that you need to take care of. So after you visit this website and you click download, and then the installer will be downloaded, and then you start to run it. So when you run it, okay, you pick the right one. Okay, someone actually is web-based. Someone would like to be a zip file. Okay, and here you will see a page after you open the installer. You have to, usually I suggest to pick install launcher for all users, add pass 3 Python pass to pass. Okay, this is very important, must do this one. And then usually I choose this one. I don't like to choose this install now, choose custom design, and then next, okay. Okay, next page, you will see something like this. This version is already a little bit old because it's a 3.7 installer, but the feature is similar. You can check every single one right here, and for all users as well, and click next. And then you will see this page. So now we want you to use a simple pass. So usually it's C/:Python33. So myself, sometimes I use a C:/ just Python. Okay, so next time you update different version, you don't have the version number. So I usually use a C:/Python. And if you want to keep many versions, then you use a 37, 38, okay, different one. You can do that. But for me, I don't need that. And then this different option, you can choose the debugging symbol and binary, but usually I don't. Okay, usually I don't. That's not required. So then you click install after this. Okay, next one. After the installation, you should see something like you should be able to see something. Let me show you. Okay, after installation, you should go to your installation directories. So for me, it's under C drive, under Python. Okay, let me go to my C drive Python directory right here. Okay. So once you go to here, there is a program called Python. So now you can use a window R. Okay, window R. Window key is the one with square. That is your bottom left third key plus R key. Okay, R key. So you bring up the runner for the window prompt, and then you type in CMD is command line. Okay, so click OK. You bring up this black window, and with the DOS prompt. okay, and you choose, you need to go to this directory. So you do cd space, copy this path. Okay, so you left click, come to the address bar, left click, select, right click, copy, come back to here, paste. So you come to here, so you have this, okay? After the installation, you type the Python, you should be able to bring up your Python interpreter already. So you do A equals 3, B equals 4, print A plus B, okay? So this environment, I'm sorry, print A plus B, and then you got 7, okay? So your Python is up and running after that, okay? And you quit, okay? You go back to C columns Python, okay? So now another way is that you can go to this lib, okay, library, Python /lib, L-I-B, and go to idle lib, IDLELIB, okay? And then here you go to a batch file called this one, idle.bat, okay? It's a window batch file. So usually I copy this one, okay? I copy this one, copy this, the whole batch file, and I put somewhere. So right here, I do pass over here. Here we have an idle shortcut. Okay, so I usually do that. But today I'm not going to do it, so I'm going to just select this idle. So start idle, and this idle is integrated development line editor. Then you will bring up Python as well. It's similar to your DOS prime version of the Python. So right here, you can also do A equals 3, B equals 4, print A plus B. You can do Python programming already. I configure the color, okay? And original color is idle classic. Okay, you do apply, it's idle classic color. So me, every time, because of the education purpose, I click highlight and then select idle dark, and it works better for online education, okay? So that's Python interpreter, and Python is a interpreter, so it's just like someone do interpretation. So you can ask question, you will answer, ask question, you will answer, just like there's an interpreter. So you have a person who is speaking English. There's another person speaking Japanese, okay? So basically the interpreter's job is like English person speak like, how are you? And then this interpreter would say, "Ogenki desu ka?" And then this Japanese person would say, "Daijoubu." And then this interpreter will talk back to the English speaker, say, "I'm fine." Okay, so these are the whole process of the interpretation between the English speaker and the Japanese speaker. Okay, so right here is the same. You do see a prompt. Okay, you do see a prompt. So this prompt just tell you the Python interpreter is waiting for your question. Okay, and then every time you do type in something, so let's do C equals 10. Okay, and then E equals A times C. Okay, A is 3, C is 10. So you print your E, you got 30. Okay, so every time you ask a question and you ask a question, you answer, this we call it Python interpreter. So first one, you have A equals 3. So A is we call it a variable, and it associated with the memory. So when you say A equal sign 3, you put a 3 over there. This equal sign really is assignment. Okay, it works as assignment. You assign a 3 into the variable. And B equals 4, create another memory, and you put 4 over there, right? And then you do A plus B, you get these two numbers to do sum, you get 7. And then the result being printed, you got 7. Then you have a C, you put a 10 over there. And then C and A, you do multiplication. you got 30, and store the 30 into E, and then you print E, you got 30. Okay. So this is the process of the interpretation and our computer programming depending on the interpreter. So we are basically talking to the Python interpreter all the time. And it's question answer based, one by one, okay? Question answer based. So every time you start your Python, you can have two ways. One is you use your DOS prompt and then type the Python. That's one way. And you can do ESIT to quit it, okay? The other way is that you actually go here, click on the idle, okay, the .bat file. And this idle is actually stored in your Python installation directory /lib/idle-like. There is this idle.bat. You have to copy it as a shortcut and pass on a location that you prefer. Okay, so this is how you get started. So if you don't like this Python idle, you also click exit. You get out of it. Okay, you get out of it. Let's try again. Come to here, double click on idle. You bring up your idle. Okay, this is idle environment. So as a beginner, this idle environment will work pretty well for you. Okay, let's go back. So that's Python interpreter. So that's Python interpreter. And we will talk about the full version of the idle later. Okay, so far we are working with the Python interpreter. So Python interpreter is a shell. We call it shell as well. Python is a interpreter language. So basically, you ask question, Python answer, you ask question, Python answer, okay? So Python shell wait for the input command from the user and then answer one by one, okay? So you finish your command line prompt and then write Python and press enter from the break window for those prompts. You will also start Python, okay? So this, actually, you get this if you start from the Windows and you type in Python, okay, you get into it as well. Okay, so now next one, we would like to execute Python script. So that is question answer based, but sometimes we don't want to actually keep typing. Okay, we want to save the result as a program. So in that way, we call it Python script. Python script is Python's program. Okay, script because Python is a scripting language. Okay, so let's do new file. Click file, new file. So this will open a file, right? And this one that's actually save as. So save as to save to any location that you prefer. Okay, that you prefer. So for me, I'm going to go to, okay, the Python course directory. Let me choose my directory. One moment. So over here, I have Python course, brief Python course. So right here, I'm going to create a new directory called PyDev, Python development. Okay, and then I'm going to go here. I'm going to create a new folder called BP1, brief Python chapter 1. Okay, so over here you can choose any name and keep it as a Python file. So here you can choose this one called first program. So first.py. So okay, and here it wants us to do this. Okay, print something. Okay, this is Python script.py. So let's do this. Let's just do print. Double quote, welcome to Python. Okay, and then print. This is a beginner CS course. Okay, so now we do two print command. Okay, First one, print welcome to Python. So anything inside double quote, it is a message, some text message, okay? And if you have the sharp sign, anything of the sharp sign, they are comments. Comments means that it doesn't count for any effect. It actually is of no use, okay? But it just keep there for documentation purpose. And documentation is very important for computer programming. And so this one usually just take a note like this, okay? So this, I finish this script, so let's do run module. Okay, and you print now, welcome to Python. This is a beginner's computer science course. Okay, so that's actually similar to this, okay? This is a script. Okay, you can also do that in your Python window. So let's go back to the window here, okay? So right here, I call Python, but I call this one. Let's see, let's look at the directory. This is not a directory I have the code, okay? So what I need to do is I need to go to my design directory, okay? So let me choose it. It is over here, and then Python course, pre-Python, okay, this PyDev inside her BP1. Okay, so I'm going to come to here, address bar, left click, select the address, right click, copy, okay? Come back to here to cd, change directory, okay, space, and then pass the pass, okay? So cd is change directory, and then the pass. Click return, okay? So I'm in that BP1. So there is a first Python file. So I say Python first.py. This will also run the script, the Python script that we just finished. And then you get the result. So this is a very convenient way. So either way, you use a Python interpreter from those prompts, or you use idle, both work. But for the beginners, I suggest to use this one called Python interpreter. So the window that we bring up when we do new file, this one, bring up this thing we call it idle. This window we call it idle. Integrated development line editor. Okay, so that's called idle. So it is an editor to compile our program. And then once you finish, you click on here, run, and run module. You will actually get the result. Okay. So this is idle window. This one is a Python shell window. Okay. They are different. So let's go back. Okay. So this give you a second way to run the Python script from Windows or from those prompts or from your idle. Okay. So idle is integrated development line editor. Okay, this one you need to copy it from the Python /idle location. Okay, depending on where you install. It's called integrated IDE. Okay, it's one kind of IDE. Okay, for Python. Okay, we got this. Okay, this we demonstrated already. Next one, let's look at Python's basic syntax. So Python has variable, word, sentence structure, and the program structure. Okay. So first thing we need to know about vocabulary and the word. So Python identifier. Identifier means a variable name or function name. Okay. So usually when you do math, you have x equals 3. X is an identifier. And sometimes we also call it variable. So identifier is the name of the variable. or sometimes it's a name of the function, or it's actually a name for the class and the module package, okay? But here we haven't teach you what is function yet. We haven't teach you what is class and module and package. So that's for the time being, do not need to spend time on here, okay? Just knowing that ID can be the name for a variable. So the ID, okay, the rule for the ID is that your variable name must start with underline or English letter. So if you have an A3, that's okay. Lowercase a3 is okay. Underline 3, that's actually okay. But you cannot start with 3A, that's wrong. You cannot start with number, digit, or symbol. No, you can only start with English letter and underline. Okay, English letter and underline. That's the rule for the ID. So no other character are allowed. So conventionally, the name of the class begins with uppercase if you use class, and we will introduce the class later. Use of the 1 or 2 underscore character has a special meaning. Okay, we call it the magic function or magic or private data. But here we don't go into that detail. Okay, so next one, you can assign a double quote hello world, that is a message. Okay, so anything inside double quote is a message. We also call it string. String is because it's a string of characters. So if the individual symbol, we call it a character. And string is a combination of characters. It is a collection of the letters. And code equals 1, 2, 3. 1, 2, 3 is a number. So code is a number that assigned to code. Okay. So right here, we do have 2 text message, name and MSG. Okay. MSG store with hello world. Code store with 1, 2, 3. Okay. Name store with Steve. Let's try this one out. Okay. Let's go back to the idle. So right here, let's do this. Let's do MSG equals hello world. At the same time, you can also do this, okay, print MSG, now print the message, you got hello world. You can also print the type of the MSG. So you'll tell you it's a string, okay, it's a string. String means the text, collection of text. Next one, we have code equals 1, 2, 3, okay? You can also print code. Code is a number, so if you print type of the code, then you will see it actually is integer, int for integer, okay? So these are basic one, the basic data type, string and number, okay, string and number. These are 2 very basic type of the data, string and number. Okay, if your string is way longer, let's try this one, okay? So if you have a MSG equals string longer, okay, I am happy, I am going to school. Okay, let's change line. Change line, you can use this, and then hit return. So you see that means that the string has not been finished yet. So I will ask my teacher, what is the homework this week? Period. Change line. Okay. I will do it. Okay. When you finish, you do double quote. So from the double quote to another double quote, this whole thing, we call it the content of a string. The backslash, just meaning that the string is too long. I'm going to use the next line to be connected to here, make it the longer string. So basically, after you do this, you do return, and then you can do print MSG. The whole content will be printed. Okay, so MSG is a multi-line string. So this is how the multi-line string works. Okay, and you can put several statements in one line if you do semicolon. Okay, so let's do this. Let's do A equals 3, B equals 4, C equals 5, D equals 6. So totally 4 comments. And let's print A, comma, B, comma, C, comma, D. So A, comma, B, comma, B, comma, C, comma, D. These 4 numbers will be separated by 1 space each. That's the power of print when you print 4 different numbers. Okay, sometimes you can also do this print. Okay, A equal is actually a string, a message, and then print A, and then return. So there is a string A equal being printed, and then A's value 3 being printed, because A equals 3 we assign over here. Okay, so that's the use of the print. So print is used to print out some number or some text, some message, okay, or some message. And you can put several messages in one line, such as let's do print, okay, I am, okay, comma, a boy, period. May I come in? Okay, so these are 3 strings being printed, each one of them separated by a space. Okay, print 3 string, print 3 text message. Okay, so that is the multi-statement. You can write multiple statement in one line. Okay, statement. Okay, statement. In English, we call it sentence. In Python, we call it statement. So each sentence has a verb. Each statement takes one action. So that is a word, hello world assigned to MSG. This is one assignment. You assign the hello world to the memory location MSG. Then you assign 1, 2, 3 to code. Then you put the code with the value of 1, 2, 3. Okay, that's one action. And each sentence, we call it a statement in Python. Okay. Okay, indentation. Sometimes we do have indentation, and indentation is very important for Python language. So let's look at this. Here we have a simple thing called function. Okay. So what is a function? Let's look at the function now. I'm going to just give you a very basic idea of what is a function. So right here, this one is the first program. Let me create a second program. So let me save as second. Okay, so we have this second program. Let me close the first one. So now you can do this print. Welcome, okay, to Washington High School, comma, okay, and then you do Arial. Okay, so we type a 2-line. Welcome to Washington High School, and Arial, okay, and then let's do period. And let's just do this. And then hi Arial, do you like this school? Okay, so let's run it. Okay, so we got the result. Now, if we need to repeat this for several times, And then we are not going to just welcome Arial. Let's actually welcome second person 80. So we can change this one for 80. This one for Carol. This one for Carol. This one for Daniel. So A, B, C, D. Okay. A, Ariel. B, Betty. C, Carol. D, Daniel. Okay. So now we can save this one as second.py and let's run it. So we print out this 4 people. But if we have more and more person coming in, then this is not going to be efficient. So we can use a program structure called function. So here, let's call this a program called welcome. And then let's put a name there, right? Now I'm going to copy these things and put it over here, okay? Let me save to another file. Okay, let's save as this one. Let's call it third. No, let's call it second one. Okay, second one. So you need to push this one in with indentation. Usually it's 4 space. Okay, usually it's 4 space. And you change this area with name. So you create a function, and this we can delete them. So now you do welcome area. Welcome. Okay. Edit. Welcome. Okay. Hero. And then welcome. Okay. This one continue. So by doing this, you can see that, okay, original function, let's actually compare, okay? Let's compare second function and this one, second program and this and second one. So this second like this, you run this one, okay, you run this one, let's actually run module. You got the identical result, but the program will be shorter because you use the function, okay? So function comes with a parameter name, and the name will be used to replace this name over here. Okay. And that's the purpose of a function. But to do this function, you need to have a concept of cobra. So cobra means that this portion belongs to this welcome. So we call it indentation. Okay, we call it indentation. So then let's actually clean it. Okay. So now let's try one thing. So here, let me put a print. Okay. So if I put it over here, then welcome area will have 3 lines. So each one 3 lines. Totally, you will get 12 lines of the result printed. So it's a welcome, okay, and okay. It's 4 okay being done. So this print belong to the welcome. But if I do delete like this, it's outside of defined function. It's not inside aligned with the indentation over here. Then this okay doesn't belong to the welcome. It's outside. It actually become outside. So what this one will happen is that you print one okay first, and then welcome 4 times, but there's no okay between them. Okay, so okay first time, Arial 2 line, Betty 2 line. Okay, so that's the power of this indentation. You must put your code at the right indentation. So this is number 3 program. Okay, so that's indentation. So indentation play a very important role in Python programming, and usually is used to determine whether the code belongs to a code block or not. A code block is the component or the code portion belong to the function say hello. Okay, belong to the function say hello. So if your code belong to it, then you can actually if your code belong to there, you need to indent with the other line. Okay. If you put outside, it actually doesn't belong to the code block. So command we talk about is actually sharp sign that will be coming in now some words, and it's not going to be useful. Next one, if you want to have a multiple line commands, you can use quote, quote, quote. Let me put on my idle. I seem to lose it. So let me start the idle one more time. Let me open the second one program. Okay, one moment. Okay, so far we can also put some comment on top of this main program. So you do quote, quote, quote. Okay. Quote, quote, quote. Okay. So here, anything between two quote, quote, quote are comments. Okay. Block comments means that it has more than one line. It has more than one line, but this whole thing, the green color one, are of no use. Okay, it should be considered to be a comment. So sometimes if you have some code that you don't want to run it, you can also do it. Okay, you can also do it that way. Okay, next one, we are going to get some input and then trying to do it. Let's actually look at this one. Okay, this is third. Next one, let's try to create a new one. This one, let's call it savers. Get name. Okay, let me close it. Save. So this one, you can do this input. Enter your name. Okay, so input is a function. You put the prompt inside a function, and it will show to people what you do, and then you assign the output, the result of this input function to a MSG, and then you print it. Let's call it name, don't call it MSG. Okay, now this is good. So that's a run. Okay. So basically, this input will get a string, and this enter your name is a prompt to show the user what you need to input. And then the input result is Arial being assigned to the name. And then we print the Arial name. Okay, so that's the purpose of getting input. The first program to get input. Okay, and you can use get input to work on different purpose. So next one, let's try to enter more data. Okay. So right here, let me go back to this get input. Okay, so you can get the name and then you can do age. Okay. Okay, because the age is a number. So you just input, this input will get a string. So you want to convert the string to a integer. So you use the integer function. Okay, so the purpose of this int function will do that. So let's do this. Okay, let's do with print name and then print type of the name. That should be string. Okay, and you can print age. And then also print type of age. This one should be an integer. Okay, let's actually save this script and run. So enter your name, Ariel, age is 17. Okay, so Ariel is a string, age actually is a integer. Okay. Now let's actually look at okay, this actually is the output. So you can display the output and get the input and display the output as well. So these are the basic talk about the basic input and output and also the text and number. Okay. And that's the most basic syntax of a program. Next one, we are going to look into the data type and variable and the expression and the statements. Okay, so these are we will start to build the program structure one by one. First thing is that you need to know about the data type. So the data type in Python, they are basically 4 basic type of data. Sometimes people say 3. It is numbers, string, and another type called Boolean type. Boolean is logic type, okay? It's only true or false. So string type, we introduced it already, is inside the double quote. Number, you have 2 type of number. So that's why sometimes we call it 4 type, sometimes we call it 3 type. So 2 type number, 1 is integer that we already know, a equals 3, that is an integer. Another type is called float. B equals 4.2, that is a float. So let's look at why it's called floating-point number. Okay, a floating-point number is actually a real number, right? So you may have f equals 3.4425. So if this number you times 10, then this decimal point will move to here. It becomes 34.425. If this one divided by 10, then you become 3.4425. So decimal point move from here to the left by 1 digit. So because the digit is moving around when you multiply 10 or divide by 10, so we call it floating point number. And floating point number sometimes can be expressed as a scientific notation. So you can write as 3.424425 E0. E means exponential 0. It's actually equal to 3.4425 times 10 to the power 0. So this number 34.4425 3.4425, you can sometimes write down 3.4425 times 10 to the power 1. And basically, this portion is the same, only the power is different when you multiply by 10. And your decimal point moving around, so we call it floating point numbers. Okay, so there are 4 data type possible, basic possible data. Number, 2 type, integer and floating point. String for text message, Boolean for the logic use. And there are 5 compound type: tuple, list, set, range, and dictionary. So these compound type we'll save for the chapter 4 to talk about it. Today we are more focused on the basic data type, the string, the integer, the floating point. Okay, integer you have g equals 5 divided by 2. Okay, that's an integer. But here in Python, integer division, we use a /2. Okay. And floating point, you can set s equals this. So let's talk about the difference between regular division and floating point division and integer division. Let's assume that we have a number, we do 13 divided by 5. So you'll be 3, okay, 5, 15, 20, 3.4. Okay, so this 3.4, we write it down as 17/5. 17 divided by 5, you've got 3.4. Okay, this we call it floating point division. Let's compare with another case that you do 17 divided by 5. You've got 3, 15, remainder 2. So this number, we call it quotient. And we also call this one integer division. So it's written down as 17/5. You get 3. So this is floating point division, single slash. Double slash is called integer division. And this 2, we write it down as 17 10 modulo by 2. This is the remainder, 10 modulo by 5. This is the remainder of the 17 divided by 5. You've got 2. Okay, so this one is the integer division and floating point division. Okay, string, you use double quote, single quote, okay? So your number, you have the integer, floating point, complex number, but complex number too much for middle school students, so we are going to omit it. Integer is positive or negative numbers, whole numbers, no fractional part. Real number is a floating point representation of a fractional component denoted by the decimal symbol or scientific notation. So basically, when you have fractional part, we call it floating point number. When you don't have it, we call it integer. So Boolean type can only be true or false. Okay, we'll talk about the Boolean type later. And then we have the sequence type. We have string, list, tuple. Okay, list and tuple, we are going to save them for chapter 4. So string is a collection of characters. So if we check the type of 1, 2, 3, 4, it's an integer. We did check the type of the 50.5, that would be a floating point number. If we check the type of 6 plus 4j, this is a complex number, but we are not covering it in this course. If we check the type of double quote, hello, that's a string. Okay. If you check the bracket 1, 2, 3, 4, that's actually a list. List and tuple, we are not covering it right now. It's also for a dictionary. So variable is something you can store some data to it. Okay. So before we know about variable, let's look at constants. So constant is a fixed value, something that you cannot change. So 1, 2, 3 is a constant. 98.6 is a floating point constant. these are values that you don't change. So sometimes we also call it literal. Sometimes we also call it literal. Okay, so now we also call it literals. It's the way that you write down the constants. Okay, you can print 1, 2, 3, print 98.6, print hello world. Okay, and then you can save them for later purpose. So you can save 12.2 to a variable x. That means that you allocate a memory location and put the 12.2 over there. And y you can assign with 14 value, and then it's also creating the memory location, you put 14 there. So you can multiply the variable. If you do 12.2 assigned to x and then 14 assigned to y, then you assign 100 to x. Then the x locations data is overwritten by 100. Okay, so assignment it can be overwriting. Okay, so the name of the variable must be following the rule for the name of the ID. Okay, must follow it. So basically, starting with letter is fine. Starting with underline, fine. Starting with number, no. Starting with symbol, no. With a dot inside the variable, no. Okay. Let's continue. Okay, so you want to have a name for each variable, so later you know about it later. So naming the variable is very important. So you can store some value like this to a very strange name, but that's not going to be efficient and not easy to remember as well. Okay, so that's a single variable. Now, next one we talk about expression. So it's single variable, we sometimes call it token. Sometimes in English it's similar to a word. And then expression is similar to a phrase, just like at the school. 3 words as a proverb phrase. Okay. Okay, so that's expression. So usually expression, you have some operator to operate with it, and you will get some value. So expression will get some value. So you do have 3 plus 3. 3 is a number. 3, this is second 3 is also a number. 3 plus 3, it becomes an expression. So expression is part of the sentence, part of the speech of the sentence. So we teach here plus minus times division. Division is a floating point division. Double slash is integer division. Also power. Power you do write down 2 star to that 2. That means 2 raised to the power 2. Percentage means division. So you have 17 10 multiplied by 5, you get 2. That's the remainder when you do the division, 17 divided by 5. Okay, so remember 33 divided by 5, you got a quotient. Quotient is using integer division. So you will write actually 23 divided by 5, you get 4. And then 23 multiplied by 5, you get 3. Okay. Okay, so when you evaluate the equation, it is similar to your elementary school's parenthesis exponent, okay, multiply and the division, and the addition and subtraction, okay, similar to that order. So this one will go first. So this whole thing will be divided to 5 raised to the power 6. then 4 divided by this number. Okay, so you have a 1 plus 2 times 3, that's 6, minus 4 divided by 5 raised to the power 6. So remember the order of the operations, which operator would take the higher precedence. Parenthesis power, okay, multiply, division, addition, and then left to right, okay? These are the order. Okay, type means that you will be, is the type of the data, okay? And sometimes you want to convert, say you have a 99, it's an integer. You want to convert it 14-point number, then use the floor function. But 14.99.0 plus a integer, that will become a 14 point. Okay, because 14 point is a longer, wider range data. Okay, so 10 divided by 2 is a 14-point division, you got 5.0. 9 divided by 2 is also a 14-point division, you got 4.5. 99 divided by 100, you got 0.99, okay? Something like that. These are the 14-point divisions. So statement is the whole sentence, we call it a statement. So we can assign x with 2, then you have a variable x, you store 2 there. Then you say x equals x plus 2. Then this number, we get it out, assigned to x, then plus 2. You become 2 plus 2. And put it back to the memory, it becomes 4. So when you print it, it will become 4. Okay, and then you can have this statement. X equals 3.9 times x times 1 minus x, and you can evaluate this question, this problem, okay, this expression. Okay, we put the 0.6 to there, and you get a value of 0.936. Okay. By conversion, you can use the integer to convert a string to a number. You can also use a float to convert a string to numbers, okay? And these are very important when you write a program, like getting input. Okay, this part easy. Okay, so we actually finished the slices for this chapter. Before we finish today's talk, let's look at one problem. Let's go back to here. Let's actually create one more program. Let's try to do this. Okay, let's try to get kilogram. You ask for input weight in kilos. Okay, and you assign to a value kilo, and kilo is a real number. Now we want to convert it to pounds. Okay, so your kilo number times 2.205, you get pounds. So that's print kilo, okay, comma, kilos is equivalent to pounds pounds. Okay, so this one we get an input that is a string. We convert it to 14 point, that's a kilo. Kilo times this, you get the number of pounds, and then we print out. This is the cycle of a input, processing, and output. Input, processing, and output. We call it IPO. Simple program structure called IPO. Okay, let's run it. So this one, I'm going to save it first. Okay, save to repository Python. Let's actually look at PyDev VP1. So here, let me call it kilo. Okay, you will ask for the kilos to 1 kilo. 1 kilo will be 2.25 pounds. Okay, so let's show you the input, processing, and output program structure. Okay, and we give you a very basic, simple introduction right here. Okay, totally we have 4 chapters, and this will conclude the first chapter. See you next time. Bye-bye. Welcome to Brief Python course. Today we are going to cover the chapter 2, conditionals. My name is Eric Chow, Dr. Chow. Today's topic, we will go over the flowchart, Boolean value, character and string, Boolean expression, and conditional structure. So before you learn programming, you need to know about how problem can be solved. And the tool to solve a problem will be using the flowchart or pseudocode. So flowchart pseudocode is the way that you document down your way of thinking. So the way of thinking is very important. And we usually use flowchart or pseudocode. Pseudocode is English-like plain language to describe your problem or your solution. So this is very important before you actually write down your program in Python. You can use flowchart or pseudocode to explain it. The next one, we are going to talk about Boolean value, character, and string. These are some other more data types in Python. They will go into the conditional statements and the conditional structures and Boolean expression to talk about what are the selection in the program. So flowchart is a graphical representation of an algorithm. Programmers often use it as a program planning tool to solve a problem. And sometimes it's used as a documentation tool so that other engineers or programmer can look at your documentation and then be able to figure out what you tried, the way that you try to solve the problem. So it is a very important tool, not only for personal documentation purpose, but also for teamwork. It makes use of symbol which connected among them to indicate a flow of informational processing. They are data flow, they are control flow, and usually flowchart is for the control flow. And you can also have another kind of chart called data flow chart. And data flow chart is usually figuring out how data being processed from one stage to the other. And control flow usually is written down in flowchart. So the way that we talk about flowchart right here mostly is talking about the control flow. So let's look at the basic symbols in the flowchart. There are terminals, input, output, and processing, decision, and connector. So terminal is the beginning point or ending point. So usually you use a rounded rectangle. This is the terminal, and the end is similar, a rounded rectangle. And input output, usually you use like this, a parallelism or a diamond shaped, I should say parallelism. And then processing, you use a square. Sometimes if it is a subroutine, you have two more line on the side. If it is just as a box, you actually use a rectangle for processing. Decision, you use a diamond, this one, vertical diamond. And connector, you use a circle. Okay, and we'll talk about how these different items being used in a real flowchart. So terminal is oval shape or rounded rectangle. And I personally, most of the time, use a rounded rectangle. And input output use a parallelism, parallelogram to denote any function of the input output type. And processing, you use a rectangle. And decision, you use a diamond shape. And usually this one, you provide yes or no, true or false route. And connector is connecting one page to the other. Usually is a stop point. So usually you go several steps, and then you say A, and then from the other page, you start from A and get started from here. That's the way you use a connector. So connector usually is a jumper between the different pages. For line, you use a line or arrow headed line. Okay, you can use your flowchart to draw down your daily schedule. So to draw this one down, you actually will write down like this. So you wake up at 6 a.m. and depending on whether it's a weekday or weekend. If weekend, you go to gym. And then you go to park. If not, then you may actually drive to your company. Okay, so some flowchart is like this. This is your partial result for the daily work schedule. You can continue to make it complete. But right here, this is only an example of how to do flowchart to draw down your daily work schedule. So draw a flowchart about what will happen if you go to the library, borrow a book, and you search on the computer. If the book exists, it may be available or have been borrowed. Then what will you do? So basically, think about the scenario. So flowchart is sometimes also related to the scenario design. Scenario design. What is scenario design? Before we write down a program, you need to know about the scenario. So let's assume that we are writing a program for the library. So library may have front desk, may have some librarian to keep track of the books. So front desk, if you talk to a front desk maybe is a information center. So she may need to have a book searching engine, okay? And then the book searching engine will tell you where the book is, okay? And then there's another desk maybe have seated with a librarian. And then you go to check if the book exists. If it exists, you would like to borrow it and then check it out. So the whole process is a scenario. Some part is a computer system, some part is human system. And then you need to design the system well first before you write the program. So this is something you can do to work out the scenarios for a person who go to the library and want to borrow a book. So write down this one. And that is a homework you can work on. But because we are continuing for the lecture, so this one will remain an exercise for you. And please try this one out by yourself. And apparently, there's no solution for this one because there are so many options. This one is just a exercise. So if we think about comparing two numbers and finding out the maximum, this is a simple flowchart. You get started, you input number one and you input number two number, and you compare. If number one greater than number two is true, then you display number one. Then number one is the larger number. And then if not, you actually will display number two. So here we have true and false involved. These are the Boolean variable. Number one greater than number two, that is a logic, and sometimes we call it Boolean variable. Or Boolean expression. Number one greater than number two is a Boolean expression. Boolean is the name of a person called George Boole. George Boole is a British mathematician, and his last name is B-O-O-L-E, George Boole. And he was a person in the 19th century. And then he laid out the fundamental work for the study of the digital system, binary logic, and also Boolean logic. So because we would like to remember him, and then all of the logic variables, we call it Boolean variable. It's an adjective term with an added to the Boole. That is the last name of the person. So usually we talk about Boolean variable means a logic variable. And the value can be true or false. In Python, the true value must be TRUE, capital T. False must use capital F. So these are the Boolean variable and the flowcharts. And flowchart usually had input box, output box, processing box, output box, and also the decision box. These are the main component in the flowchart. So we may have conditional steps. So let's assume that we have x equals 5. When x less than 10, we'll print out it's actually smaller. And it's greater than 20, we'll print bigger. So that is a program for the guessing number problem, okay? And then this is the flowchart. So Boolean value, you usually, when you try to describe some solution of a computing problem, or you try to talk about some decision, you basically voted for yes or no. And some in Python language, we talk about true or false. In some language, true is actually 1, false is actually 0. But here, we only use the true or false in Python. So when binary decision need to be made, we will need to use a Boolean value. So Boolean expression is a expression that uses a Boolean variable or Boolean constants. A Boolean value is true or false. We talked about it already. Two values, true or false, 0 or 1. And then Boolean expression is the combination of the Boolean value and the Boolean operators, plus, minus, greater, less than, okay, those kind of the operators, and you form a Boolean expression. So Boolean expression sometimes is, you may have n greater than n. This is a Boolean expression. You may have B1, okay, Boolean, and then and B2, two Boolean value using the AND. So AND is a Boolean operator. So Boolean expression will typically return the value true or false. N greater than M, it may be true, maybe false. Sometimes we write down T/F. And B1 and the B2 also may be true or false. So B1 can be like, let's assume that B1 is actually a logic term that you are happy. And you are happy may be true or false. B2, let's assume that you are rich. So when you are rich and happy, then B1 and B2 will be true. If you are happy but not rich, or rich but not happy, or not happy and not rich, then this will get a false. So basically, Boolean expression is the combination of Boolean variables or a calculation of some inequality or equality expression in the math. So comparison operator look at the variable and do not change the variable, but they will evaluate the variables and combination to provide a true or false value. So comparison operator, these are 6 comparison operators. So mathematically, you write down less than equal to as this. Equal, you write down like this. Greater than you or equal to, you write down like this. Not equal, you write down like this. But you have to use the Python symbol in Python language. So there is no such thing as equal, greater than. No, it's only greater equal. The order must be exactly the same as what we described over here. So these are 6 basic operators to determine the Boolean value, Boolean expression. So we have x equals 5. If x equals 5, we print out x equals 5. So when x equals 5 is true, then we print this. This is one of, we call it if statement. So if x greater than 4, this one you need to follow by a column. If x greater than 4, yes, it is greater than 4 because it's actually a 5. So you print greater than 4. If greater equal to 5, you will print out greater than equal to 5. That actually is true. If x less than 5, you will print out less than 6. You print out less than 6. If less than equal to 5, you will print out less than equal to not equal 6, you print out not equal 6. So these are all true. Everyone is true, and you will print out the corresponding message. And one thing you need to take care of is here also have the full space for indentation, and then this print statement belong to this if statement. So that's a COBRA concept. Character, okay. Character. So we transmit the data by email or actually store in computer. And every English letter have its own representation. We call it ASCII code. ASCII code is short for American Standard Code for Information Inter-Exchange, ASCII, okay, ASCII code. And then A, okay, A is stored in computer as decimal 65 or hexadecimal 41. Hexadecimal number, we use a 0x. It is a base 16 number. Okay, base 16 number. So basically, 0x41 would be 41. 4 is representing 16. 1 representing 1. So this one would be 64 plus 1. So the value will be 65 is the ASCII number, ASCII code for A. So A started from 65 to 90 for G. And then lowercase a starting from 97, that is hexadecimal 61 to 122 for lowercase g. So these are the numbers the ASCII code numbers for the letters. So if you say the order of A, you got 65. That is the ASCII code number in decimal system. And then if you say character of 65, you get A symbol. This one is A single quote, single quote. Single quote means a letter. Okay, if you just put an A, that maybe is a variable name. Okay, let's look at the idle and then see the difference. Right here, just looking at these slices, you don't feel of how the computer system will work. So let me actually close my slices. Let me bring up the idle. So you bring up the idle again. So you say A equals 3. This A is a variable. This is not a symbol in computer. So you will store a 3 in A. Okay. Now you print it. Okay. And this is not a character. This is not a character we talk about. So a character actually is a message. So we can say A equals A, single quote, single quote, A, single quote. This A now stored with a symbol. And this symbol will be A. Okay, and then it actually, in computer, it will be 65. Or in binary number is 0B. 0B means a binary number. And you have 0, 0, 0, 0. I'm sorry, 0, 1, 0, 0. And then 0, 0, 0, 1. This one also, you can write down a 0s41. Hexadecimal value. And the 0B is binary number. So this one is a A you store in the computer. And when you print A, you've got the A symbol. And if you check the order of this A variable, you got 65. If you print the CHR of order of A is order of A is 65, and character of the 65 will be going back to the A character again. Okay. So order function and character function is a forward and backward reverse function relationship for the ASCII code. And the next one is Unicode. Unicode is needed when the computer trying to incorporate all of the non-English letters. So English letter is very simple because it's only 8-bit. IBM extended ASCII code would be enough to represent all of the English labels. But in something like Chinese letters, you cannot use the ASCII code to store it. So in that case, what can we do? We use Unicode. So you can search the Unicode internet for Unicode. Okay, Unicode is the word character standard for text and emoji. There are all kinds of symbols that you can use. Okay. And they have different range. So you can also actually try to search using multilingual print in Unicode. You have print 0, you will get the image, and this will tell you what is print 0. Let me open it in the new tab. Okay, so basically, you extend the the ASCII code from 1 byte. 1 byte is 8 bit to 2 byte. 2 byte is 16 bit. So the first 8 bit is 00. This one reserved for the English. And 01, 02 is reserved for some European languages. And as you can see here, there are a lot of the pink color region. These are mostly Chinese symbols. And then there are some darker pink colors. These are usually for the Southern Asia language, such as Indian Hindi or some India language or Thai languages. Okay, so this one is a multilingual print. Just to tell you that the characters are represented by 60-bit. For example, my last name Chou, C-H-O-U, you can assign it by Unicode. So you take single quote /U 5468, and you can print Chou. This is the Chinese character that for my last name Chinese letters. Okay, so /U 5468. So you can also use Chou equals 0x5468. This is a hexadecimal value, and you print it for Chou. You get this number, right? And let's try to use Chou equals CHR or the Chou. And then we print CHOU. You get the same character back. Okay, so CHR and the older numbers are a pair of functions, not only working for English, but also working for all the foreign languages that we call it Unicode. But right here, we will stop the discussion of Unicode up to here, okay? Going further would be more difficult. That's not the purpose of this chapter. So Python would use 16-bit Unicode. We call it UTF-16, okay? Okay, these are the ASCII code portion, okay, hexadecimal and ASCII code. So what you need to remember, more important part is from 41, this is a hexadecimal value, to 58, that is 90. This region is uppercase English label. Also from 61 to 7A, that's A to Z, from 97 to 122. Those are the lowercase Englishes. Also from 30 to 39. That is the region for the numbers. Okay, these are something you need to remember. Usually these are more valuable ASCII code information. And then more general Unicode or English, okay, is right here. But this one, as you can see, is 0030, so it actually is a 16-bit format. String is a collection of the characters. So string usually store some message. So string in Python would have single quote, such as my Chinese last name, double quote, AA, that's also a string. Triple quote, that's also a string. So you can put triple quote, A, B, C, D, E, F, G. So single quote, double quote, triple quote, they all represent for string in Python. You can also have the double quote, but nothing in there. This one actually is a empty string. A string with no data. That's also legal expression for string. So string is a data collection for the text. you represent your name or sometimes your address, okay, in string. So you can declare a variable 1 equals hello world, variable 2 equals Python programming. So hello world will be stored to variable 1. Hello 2 will be stored in the variable 2. Let's look at the idle. So you can have another one. You can have A equals welcome to Python. B equals Mr. Johnson. And then you can do this print A comma B. So print out 2 string, and you become welcome to Python, Mr. Johnson. You can also say C equals A plus 1 empty space plus B. And then you can print C. So plus sign is a connection of the 3 string, A string, and 1 space string and B string. So these are the basic string definition and its operations. So string is used for the processing of the text. And text is one very important part of the programming when you need to describe something using English. So here, a string is a sequence of characters. A string literal use quote, single quote, hello, single quote, or double quote, hello, double quote. There's no difference for using 1 single quote or double quote. For string, plus sign means concatenate, means the connecting 2 strings together. So string 1 is hello, string 2 is there. And then your Bob equals string 1 plus string 2. So when you print Bob becomes hello there. And then string 3 is 1, 2, 3. String 3 plus 1 is 1, 2, 3 plus 1. That 1 is not a string. So you cannot edit the string with a 1. If you want to add the string 1, you should use plus double quote 1. Okay, that will solve the problem. Or you convert the string to integer. That would be okay. This one is convert a string to integer. So you get what? You get 1, 2, 3 plus 1. You will get 124. So remember the plus sign in integer, that is the arithmetic addition. But in string, that will become a concatenation that's connecting 2 strings together. So we prefer to read data using string and pass them and then convert the data that we need into something else. Okay. So let's actually look at this one. Let's look at one problem. Let's go back to our idle. I'm going to create a new file. So this new file, I'm going to get this. Okay. I'm going to get C equals integer input. So I'm going to input expecting an input string and convert it to integer. So enter the Celsius temperature. I got C. And then you add the Fahrenheit temperature would be C times 1.8 plus 32. So then this is input, processing, and an output. So then we do print, okay. C, okay. Degree C, okay. is f degree f. Okay, here I use a double quote, single quote. It actually both are representing string, so there's no difference. So I will save this program to a location, and this sample code you should be able to download from my course image. Okay, I store right here. I'm going to create a new directory called BP2. I'm sorry, I type in the same number. Okay, in BP2, I'm going to store this one as temperature.p1, temp.p1. Okay, so you expecting me to enter a number in Celsius. Let's assume it's actually 100. So you convert it to 212 degree F. Let's go back. Okay, let's go back. So we can do print C. Okay. Slash U212103. Okay, is F slash U2109. Let's try this one out. So 2103 is the degree C symbol. 2109 is the degree F symbol. Okay, so this one shows you the use of Unicode as well. If you want to have the temperature symbols. Okay, let me save it one more time. So anyway, these are the use of the basic string. So next one is the accessing of the string values. What is accessing of the string value? We store the string for so many characters in one string variable. So variable 1 is hello world, variable 2 is Python programming. So if I check variable 1 is 0, this index location 0 is H. So it started from 0. So you have hello world exclamation mark. The index 0, 1, 2, 3, 4, space 5, 6, 7, 8, 9, 10. 10, I put another 0. Exclamation mark 11. Okay. So when you say the value variable 1 of 0, you got H. Variable 2 is Python language programming, so you get 1, 2, 3, 4, but not including 5, N, so you get YTHO for the second printing statement. Okay. Next one, looking inside the string. So let's assume we have a string called banana, and the index starting from 0. So you have the index 0, 1, 2, 3, 4, 5. The length is 6, but 6 has no data. Let's assume this is string number, we call it N. So this would be 0 up to N minus 1. Okay, N is the length of the string. So the length of the string, you can use the len of the string to figure out how long it is. So for example, your variable string is called float. So you can use the len of the float. It will tell you how long the string is, and you got a 6. So you say float 1 assigned to later. So float 1 is later A, you'll be assigned to the later, and you print later, you got A. When x equals 3, x minus 1 equals 2, and you assign the character 2 to W. W is a N symbol. So a character too far. So let's assume that is ABC. You print that file. We only have the index 0, 1, 2. That file doesn't exist. So you will get a exception, a warning of the string index out of range. So you get a Python error message. So you cannot go too far. You cannot reach some variable or some character that's not even exist. It is not equal to do that. And you can print out the length of the float that will give you 6. And the length function is to calculate how many characters inside the string. So it can be a value from 0 to any arbitrary integer. Okay, so we can actually have the length function. So, okay, this one calculate length. So update the string. Okay, now one more thing. This for loop. Okay, let's look at the for loop. So you have a string called banana, but you want to print out each character. What can you do? Going back to here, let's try another one. Let's call create a new program. Let's call it banana. So we do have a string. Let's actually call it string s equals banana. Okay. So you want to look at every character. So you say for every character in banana s, you print ch. So this we call it for loop. For loop is that every time you get a character from the banana and you print it. So that's to print and parentheses. Print parentheses will print an empty line. So you will get banana and then space. Okay. If you want to do this, you want to do for each ch in banana, put the banana here and print ch. That is also fine. You will also print banana again. That's each of the data from the string. So use a string variable or string value. It doesn't matter here. Okay. You can also do for I in range. Range is a function. Let's assume we use a range 6. 6 is the length of the banana. You print the I. So range function will generate a number from 0, 1, 2, 3, 4, 5, but not including 6. From 0 to 6, but not including 6. So you print banana, 0, 1, 2, 3, 4, 5. Now, you can also print it as the S I value. So you will also print a banana because that's each accessing each character by index. So you can also change this 6 to length of the S. Length of the S is 6. Then you will go through every character assembly. So it's another banana. Okay, so these are the way that you access each individual characters. There are many functions that you can use. Okay, so characters, they may have the escape sequence. Let me check it. Okay, one more time. So we finished that with actually update string. Okay, let's look at this update string first before we go into the characters. So you have a variable 1 equals hello world. You can print update string and then :6. :6 means that you are starting from 0 up to 6 plus Python. So 0 up to 6 is 0, 1, 2, 3, 4, 5, but not including 6. So it's a hello space. So hello space plus Python, you get hello Python. Let's try this one out. Okay, let's assume we have a string equals hello world. B equals Python. And then we would like to point S from 0 to 6 plus B. B is Python. You get hello Python. Okay. So you can always try it out with the idle environment. So here we have some escape sequences. So what does escape sequence mean? For example, the \n is a new line. We already show you \u will give you the in recall, okay? And then \f is form fit, \t is tab, okay? So let's try it out once. So right here, let's do point A /t, B /t, C /t, E /n, E /t, F /t, /n. So you got this, okay? So basically you have A /t that would be tapping, and then B tapping, C tapping, and then D change line. /n is change line. And then E tapping, F tapping, and then change line. So you get such result. This is a so-called escape sequence. But sometimes escape sequence is for this. If you do double quote, // it will just print out single / because / is treated as a spatial character. So escape sequence usually is treating for the spatial character in Python. So / will print out a single / later. So sometimes you may want to print out a quote. So you can do print single quote, / double quote, and then A / double quote. That will give you a double quote, A double quote, because / double quote is double quote. But you can also do this, okay? You can also do single quote, double quote, A double quote, single quote. That will also print out double quote A, okay? You can also do this print, okay? Double quote, single quote, A, single quote, double quote. And then you print out the single quote. So if your data is if your outside string start and string end symbol is single quote, then double quote would be okay to use. If your start and ending symbol for the string is a double quote, then single quote symbol can be used. Okay, these are the rules. If you need to design your own string when you want to print them. So these are escape sequences. And here we do have some slicing rules. So these are slicing rules. I would just talking about the basic rules, okay? So plus sign, you will connect two strings together. This is a operator. So you have A plus B. A is hello, B is Python. You connect it as hello Python, okay? Times means you are going to repeat it several times. So A times 2 is hello, hello, give you 2 hello, okay? Then brackets is for a single element access. So A1, you get E if your A's index 1 location is E, okay? And the column use code range slicing, so you will have two number, 1 to 4, 1 included, 4 not included. So you have H, E, L, L, O, so 0, 0, 1, 2, 3, 4, 4 not included. 1, 2, 3 is ELL, you get ELL. 4 is not included. So in, you check if the character is inside a string or not. So H in A is true, will give you true, okay? Now in M in A, that will give you false, okay? So M not in A will give you true, okay? So when you use R slash, okay, that would be a row string. Row string, you don't care the escape sequence, okay? And then percentage is formatted string. Okay, let's look at formatted string. I just introduced the basic one. We would actually teach you more complicated formatted string later, okay, in other course. So let's assume that we have temperature, okay, percentage D, backslash N. Backslash N is to change line, and right here we have percentage. So you need to use a percentage operator. So this one, let's assume is 32. So this is 32. Okay, if there in the middle there's a percentage sign, this is 32 will be used to replace the percentage D. Percentage D is a single integer. So when you hit return, you print out temperature 32 because you and change the line because your 32 is used to replace the temperature. So let's assume that you do have the temperature percentage D, and then you use a backslash U 2103, okay, is percentage D, okay, to backslash U 2109, and then backslash N, okay. Now you use the percentage sign, and then you put your replacement character at the end, and then you use 100 and the 212. These are two numbers. So first number 100 will be used to replace the first percentage D. 212 will be used for the second replacement. And when two number, you have to put in the parentheses. When you do two number, one number you put it outside the parentheses. Okay, so two number you put there, and this is a two number, we call it a tuple. So this is a tuple of two values. Tuple, tuple. You get this, okay? That's the use of the formatted print. And in the more advanced course, Python 31, we'll teach you the complete version of the slicing and string formatting. Right here, we just give you a simple introduction. Okay, next one. Okay, we can look through the string. So foo equals banana, index starting from 0. While some condition is true, you continue to do this. So this portion belongs to the while statement, okay? So you will get started from index equals 0, and then you, when the index less than the length of the fruit, you assign a fruit's index number. So when index equals 0, you will assign B to the letter, and you print out the index 0 and letter B. And then index increase, then your index become 1. Then you print out 1A, 2N, 3A, 4N, 5A, respectively. Okay? So let's try this one out. Right here, let's do S equals banana. Okay? And then I equals 0. Or let's do while loop. While I less than the length of the S, we do this. Okay. So this one is in idle, you have data type. That means that this while loop had not been finished yet. So that's a print the I and the SI. And then this one, you will have I increased. I plus equals 1. Plus equals 1 means it's increased by 1. You can also use I equals I plus 1. And this is the empty line. You hit return. So you get these. Okay. Same as the slices. So you can also look into the string if you put every character. This one we talked about it before. Okay, the same. Okay, this one we have a word called banana, count equals 0. We want to count how many A. So if the letter equals A, our counter will increase and then we'll print count. Okay, this one, it will check every letter and see if the letter is A. Okay, so that is when you do for every character in the banana, you print out the characters. We call this letter as loop variable. And one iteration is one run of the loop. One run of the loop. Each iteration, the variable can be different. Okay, next one. This one we have banana. So we can have a flowchart. See if it's done. It's done. Actually, it's you run out the letters. If not, you get one letter and then print it. Get one letter and then print it. So we do percentage 4F. 4F is 14-point number and then 4-digit after decimal point. 0.4 means 40. So we print it after here. This will be included. So percentage G comma percentage you print 3 for D, 4 for D. You print out 3 comma 4. So here we have more string formatting operators. Okay, we have more string formatting operator. C for character, S for string, I for decimal integer, D for decimal integer, U for Unicode, unsigned integer, unsigned integer. E for 14-point in scientific notation. F for 14-point. Okay. This portion we kind of are more advanced. You can actually make sure that you have that justified or not. Okay, these are more complicated. Okay, there are some more advanced string functions such as find, count, lower, upper. Let's try this different one out. Okay, just give you some example. So let's assume that we have S equals computer science. Okay, and then S dot count on the number of the letter E. You got 3. Okay, that's 3. And then you can say print S dot lower. You print the lowercase for the string. You do print S dot upper. You convert it to uppercase. Okay, these are the basic operations, the different function. Okay, you can also do strip. What is strip? Let's assume we have a S equals space A, B, space. So let's do print S dot strip. So S.3 was to create a new string, but the leading and lagging space are deleted. Now let's look at it. If you have this S and I do print S dot right strip, the right side space will be stripped, but not the left side. If you do print as the left strip, you strip out the left side, but not the right side. Right side still has some space. Okay, then there's another function called for S-stub format. That is formatting a certain string. So that's more complicated. We don't introduce it right here. So here you have a slicing. So you have Monty Python, you have 0 to 4. 0 to 4 means that from 0 up to 4, 4 not included. So you can mount. 6 to 7, 6 to 7 is 6 to 7, but not included 7. So you have a single letter P. 6 to 20, you started from 6. 20, you do not have it, so you print out the whole Python. 20 is out of range. When it's out of range, you will go up to the end of the string. So column 2, you started from the beginning. When you see column, you actually assuming it's starting from 0. So up to 2 not included, so you come MO. From A to the N, A to another one. This one, if it is missing, you assume it's N, so it's 12 in enter. So you will get THON. If you do column, that is the whole thing, starting from 0, ending at N, so that would be the whole thing. Okay, and then plus sign for concatenation, we know it already. And you can use the in to check if a letter is inside the variable or not. Okay, you can check it as if it is inside or not. And then you can compare to string. So word compared to banana is actually the same, so you print out the same. If word is then banana, you will use the alphabetical order to check it. So basically, you are using the ASCII code to check which one comes first. Less than, smaller number means actually it starts from, it's actually a smaller ASCII code. Okay, here are still many more functions. Okay, we don't touch these different functions. And search is searching for the location of the combination. So when we say put define an A, it will give you 2 because the position of the first occurrence of an A is at 2. You will find Z, you cannot find Z, so you will return -1. -1 means not found. So this uppercase, we know it. You can also do replace. So hello Bob, you can replace the Bob with Jane. So when you print the new string, you get hello Jane. Okay, this string we talked about already. So you can also check if the string start with please or end with something. Okay, this portion are too hard, so we go up to here, okay? One-way selection. Now we have already finished the character and string, so we know some data type. And we go over the basic understanding of Boolean value as well. Now it's time to discuss the programming structure of the selection. So let's look at the one-way selection. So one-way selection, if you have a phi, you said before phi, equal phi, you do the following things, okay? And then you put up to phi, before phi, whatever. Actually, here you have a diagram. You have x equals phi, okay? If yes, you're going to do this 3. If not, you bypass them, okay? So if not, you will actually do up to 5, okay? And if it's 6, you will actually say print another one again. You print the similar structure as well, okay? And then you print up to 6. Okay, so this is a little bit complicated. And the indentation is for code block. Okay, let's look at this example. This one is interesting. Let's look at it. Okay. So basically, let's go to create a program. Let's call this one new. Okay, this one is called one way. Okay. Save to the same location we have. Okay, I'm going to save it to the BP2 again. This one is called it one way. Okay, let's get started with the x equals 5. Okay, we do print before 5. Okay, and then we will check if x equals 5. You have a parenthesis, no parenthesis is the same, but that's this here is a Boolean value. With or without it actually doesn't matter. So we print is 5. Okay, and then print is 0, 5. And then you print certified. Okay. Okay, up to here. Okay, up to here. Up to here, we run it. Oh, there's an extra quote. Let me delete it. Okay, one more time. Let's see. That's wrong. So x equal 5, you would actually print out before 5, so is 5, still 5. Okay, so 5. So right here, that's actually put it as a 6. Then you only print before 5, and this will be skipped. Okay, so this selector choose not to perform anything. Okay, so that's actually the x equals 5. That's a one-way selection. And the flow chart is like this. Okay, that's actually continue. So right here we do have point. Okay, afterwards 5 point before 6. Okay, if x equals 6. We do the same thing, so let me copy it over since it's repeating similar pattern. So I'm going to change the 5 to 6. But you need to keep the same indentation. So the indentation need to be here. This one is for this if x equals 5. This one right here, this one is for x equals 6. Then you print another one. Print afterwards 6. This afterwards 6 has nothing to do with the if statement. Same thing right here. This afterward 5 has nothing to do with the if statement. I put the print nothing that will give you an extra line of the space. So if we are 6, if we are actually if we are x equals 5, we will print before 5 and then the 3, and then after 5 and before 6 and after 6. I'm sorry, it's after 6. One more time. So this one just to show you that the 6 part is bypassed. Okay. So now if we change to 6, then run it, you will get bypass the 5 part, but actually go into the 6 parts. But if we have a 4, then both of them will be bypassed only before 6, 5, after 5, before 6, after 6. Okay, this is the purpose of a single decision, single one-way decision. Okay. Okay, you can turn off the tab, but that's something you can do. Okay, and then you check the indentation label. We are going to bypass this portion. Okay. Okay, these are too complicated, so we bypass this portion. Next one, we are going to talk about nested decision. Okay, nested decision. Nested decision means that inside a if statement, there's another if statement that's called nested decision. So x equal 42. If x greater than 1, we print more than 1. Then inside the greater than 1, we say if it is less than 100, we'll print less than 100, all done. Okay. So now if x is 42, you print more than 1. If less than 100, you print less than 100. So both got printed. If we have 120, then you go to the loop. You go to print more than 1, but the less than 100 will not be printed. So this one, you can see it actually divide the whole space into 3 regions. 1, 100. Okay. Under 100, you're going to print nothing. And then from 1 to 100, so from 1 to 100, not including 1, but up to 100, including 100. This portion, you print more than 1 and less than 100. More than 100, and anything, any number, you print more than 1, but not going to print less than 100. And then you print all down in all cases. So let's try this one. Okay, let's try this one. So this is one way we have done. Let's create another one called nested. So we have x equals 42. Okay, if actually x greater than 1, okay, you print more than 1. Okay, if actually x less than 100, you print less than 100. Okay, and then at the end, you're going to print all done. Okay, this is the algorithm. Okay, let's try this one now. Okay, so x equal 42. You print both. Okay, so let's change it to 0. Then nothing will be done, so all done. Okay. And if you try 101, 101 is more than 1, but not less than 100. So you print more than 1, but not less than 100. Okay, so these are the nested if, some if inside the if. So this whole thing belongs to x greater than 1. Okay. And then this portion belongs to x less than 100. Okay. When it is true, you got wrong. Got wrong. So this is the nested if. Let's move on to the next section. Okay. Next one is two-way or multiple way selection. Okay. So let's look at two-way selection. Let's look at two-way selection first. Okay. So two-way decision is that you may go yes or no on certain thing. Okay. Let's look at two-way now. So this one is save as two-way. So we do have x equals 4. And then say if x greater than 2, then we say print x is bigger. Okay. And then we say else. Else is when you are false, when x greater than 2 is false, your print A is smaller. Okay, let's look at this one. So x equal 4, you will get x is bigger all time, okay? And then you change to 1, you'll get x is smaller, O is done, okay? So this quotient is for this two-way selection, okay? Then, okay. The next one is multiple way. Sometimes you have more than one way. So let's look at this small, medium, and large. Okay, small, medium, and large. Let's copy the two-way to multiple way. Okay, two-way to multiple way. So actually, when it's less than 2, we call it is small. Okay, next one, we actually would do, okay. So it may be greater than 2, but in less than 10. And this one, we'll call it medium. Otherwise, we'll print as large. So this one, as you can see, you divide the number line by 2 value. Less than 2, this portion is small. Okay, and then greater than less than 10. So in the else part, you belong to this portion. All the else belong to this portion, right? And less than 10, so it will be actually from this point up to 10. This portion, you call it medium. And then greater than 10, you call it large. Okay, so these are the number line will be divided in this case. Okay, so let's try R1. This one should be small. I'm sorry, I'm missing another quote. So 1 is actually small. Let's look at 4. 4, you get medium. Let's try 14. 14, you got large. So this one, as you can see, this one you have these two aligned. So 2, you go here, 4, you go this one. Okay. And then the same 10, 2, you will go here, 4, you will go here. But let's assume that we have more than 2 conditions. You may have x less than 1, okay? Else, if x less than 2, else, if. So when the number of labels have more, then this way of writing the program will become a problem. Okay, it will become a problem because your program is tilted, not easy to read, and also not in good style. Okay, so to solve this problem, let's actually save this one as multiple way 2. So you can combine this else into an else if statement. And this will not have your program tilted. So you become a 3-way selection. Okay, but you can actually try more. Okay, try more. You can have another one. L if x less than 20. Okay, and this extra one, we call it extra large. Okay, let's try 22. This becomes four-way selection. Okay, so that's how we use the multiple way of selections. Okay. Okay, next one we're going to talk about conditional statement. Okay. Conditional statement is that your A can be assigned with 3 if x greater than 4. Otherwise, you will actually assign 4 to A. So the true part over here, false part over here, you assign the value to A if x greater than 4. If it is true, you assign 3, else you assign 4, okay? So that actually is the if conditional statement. Let's look at this one. So let's try another one called conditional. So this one, let's try this, okay? Let's try x equals 7, okay? And then size equals small if x less than 4, else large, okay? And then we print size. So we will assign the size of the shoes. If less than 4, we call it small, okay? Greater than, we call it large. So 7 is large. And we change this one to 2. So size 2 shoes would be a small one. Okay, these are the basic simple conditional statement. It's very, very useful. So next one, we have a lab. So this lab is the calculation of salary. So if you will enter 45 hours, enter the rate 10, and you calculate the total number of the money you need to pay. Okay, so it'll be 40 times 10 plus 5 times 5. Okay, so basically we write the program computation to keep improving 1.5 times the rate for the hour 15. Okay, for the extra money you more than 40 hours. So if under up to 40 hours, you pay the base salary for $10. And then any extra hours after 40, they will receive 10 to 15%. Okay. So you will write a program that is. Okay, let's try this one. This one is called salary. So let's see, you have two rates. Base rate is $10. Okay. And then extra rate is actually equal to 15. Okay. This one is the base times 1.5. Okay. So now you will enter hour. Into the hours, and then okay, but this one you need to convert it to integer after you enter the base salary. So you can put this under the base. But right here, you do not need this one. Okay, so we will X for number of hours and then get this. Okay, so now your base would be up to limit be 40. Okay, so if your hour less than 40, less than equal to 40, you print, okay, hour plus hour, okay, times base. You print this whole thing. Okay. Your pay is hour times base. Otherwise, your print, your pay should be 40 times base plus hour minus 40 times extra. Okay. So now it's wrong. So the hour is enter 45. Base that put 10. Okay, it's not supported instance integer. Okay. Basically, hour should also be a string, should be an integer. So let's convert it to integer as well. Sorry for it. Okay. So you enter 45 hours, base $10. You've got $475. So it will be the same as what you get right here. Okay. So we will be up to here today. Thank you. Bye now. Welcome everybody. This is Dr. Chow, Dr. Eric Chow. Today we are going to cover the chapter 3, loops. And we will also cover the functions. So loop and functions are two major program structure in Python language. So we will start with the function first and look at loop later. So first, function. Function usually is an important program structure that you use to call some sub-program or smaller piece of a program. And you can use the program for many times. And sometimes it also provides a abstraction for certain programming structure to help people to simplify the program to handle the complexity. So let's look at first example of the function. So sometimes we have two numbers. Let's assume A equals 3. B equals 4, we can find the maximum. So maximum of the A and B, we will get 4. Minimum of the A and B, we will get 3. Okay, and the absolute value of the A minus B is the distance of these two numbers, that would be 1. Okay, something like this, we call it function. So function is a set of program that written by people before and provide service for you. It is the same as the function in math. So when we say a square function, f of x equals x squared. So this is a square function. You have an input parameter. So there is an input variable or independent variable, or sometimes we call it parameter. So we can input a 2, and then the output will get 4, and this output we call it return value. Okay, so these are the structure. So a mathematical function, we have some input variable, independent variable, that is x, and the output is x squared, and y we call it a dependent variable. It depends on x, and the value is return value is 4. So this is basically the function. And function's main purpose is to simplify the program. Second, provide abstraction. So you can treat a function as a black box, provide input, and you get some output. And also, a function can be made a call reusable. Okay, so these are the purpose of the function. So let's go back to the slides. So right here, we do have a function, and then we define since function. So this is since function print hello and print have fun. And then, okay, and then this is the definition of function. And then you can call the function. So this one, when you see since parentheses, you call this function, and you perform print hello and print fun. And then you print zip. And then you do since again, you print hello and print fun again. So this portion, we call it the definition of the function. And functions call starting from the definition line up to where? Up to the code that is had the indentation. So this portion belongs to the defined function. And outside is a since and print zip. It is aligned with the definition word, then that is not part of the function. So you use the indentation to define the range of the call for the function. So there are two kinds of function in Python. One is a built-in function, such as the maximum function, minimum function, absolute value function, print function, input function, random function, float function, int function. These are functions written by people, and it is stored in the memory, and you can always call them. We call it library functions. And function we can define ourselves and then use. These are the second type of the function. We call it custom function. So function definition. In Python, a function is some reusable code that make arguments. Arguments is parameter, or sometimes we call it input. And then do some computation and provide result or output. So define a function using the def result word. Your function will get started. Then anything that have the indentation inside the def function is considered to be part of the definition of the function. Until there are some word that's outside the definition of the function, then and they are aligned with the def word, then we consider those are outside the definition of the function. And we can call the function by using the function name and the parameters. Built-in functions. So maximum function is a built-in function. So when we max hello word, That's it actually is weak. So hello world is a string. So when you do maximum, you'll find the maximum word later that with the maximum ASCII code. So that would be W word. W later. Okay, when you find minimum, you will find the smallest word later. That would be your space 32. So here you don't see anything. It actually is a space word, space later. So maximum and minimum function can be applied to string to pair of numbers list and any of the data collections. So maximum function, okay, a function is some stored code that we use. A function takes some input and process and generate an output. So this time your input is hello world, a string. Output is W, a single letter string. Okay, this one, a function is some code store, okay, is, okay, we get it. Next one, type conversion. So there are certain type of type conversion functions such as a float function that will convert an integer or string to a floating point number. So 99 will convert it to 99.0 and then divided by 100, so you got 0.99. And if you check the type of a 42, that would give you an integer type. So int function or float function that will convert the data type. Convert from integer to float in this case. So built-in function of the conversion of the function including the int function that will convert a string or floating point to integer, or float function that converts integer to floating point number, and also string function, str function that will convert an integer to a string or some other data type to a string. And there is also another one called eval function. Eval function may convert a string into a number or a data collection. So if you do have an eval and then a string 1, 2, this will be evaluated to a pair of numbers. 2 numbers will be returned. So there's also a eval function, evaluation function. So let's try to use the Python interpreter. Going back. So right here, let's assume that I have a string of a comma, let's do 1, 2, 3. That is a string. Okay, so let's do s equals 1, 2, 3. And then we can do eval s, and let's do a list equals eval s, and then we try the type of al. It is a list type. So basically, any string using the eval function, it may eval to a number or eval to a list or a tuple. So let's try another one. Let's have a b list equals eval of parentheses 1, 2, 3. As long as the format actually following the tuple format, then you will be able to eval the string into a certain type. Okay, we can also do I equal eval 10 as a string. And then we can type I, okay. So this is eval function. Sometimes you can combine the eval function with input function. So input function would actually get a number, get a string from the console. So here let's do string. Okay, you get out. So let's do S equals input. So at this moment, the input S is actually a string type. So in this case, you can use a D equals eval input of enter and integer. So enter an integer, the input of enter an integer will get a string, and then that got eval to a number, and that number is integer type. So this is combining the eval function and input function to get some value. So type conversion function are also very important. So you also have the string conversion function. You can convert some integer to string, so such as I equals 3. Then you do SS equals str of I, then print SS, and then type of SS. So SS itself is a string because you convert your I to SS data type. So that is a string conversion function. So you can convert a string to integer by using type or eval function, and convert integer back to string by str function. Custom function. Custom function are functions defined by the user. So we create a new function using the keyword followed by optional parameter in the parentheses. Indent the body of the function. This defines the function, but does not execute the body of the function yet. So let's look at the example. So right here, let's define a function. Let's assume this is a square function. You use define that actually start the definition of a function. Then the function name square. Then the parameter x. Then you can return x square. So this is the definition of the function. But if you want to run it, this is not enough. Then you need to say d equals square of 2. So d will be the output of the square function with input of 2. So then let's print it. I'm going to save this code to a certain location. Okay, let's save it as a square.py. And you get 4. That is the value that returned by the function with the input of 2. So this we call it a user-defined function. So sometimes you want it to be some function. Sometimes let's try again. We can define a function. So print okay, so welcome someone and then print is the prayer of our pleasure to see you. But remember the function's body up to the indentation finish. So if I leave a line and then I continue to follow the indentation, so this is considered part of the function. So this function finish only when you start to run a code here. Then the function stop before this line. Okay, because the indentation level is different. Okay, this welcome function. Okay, but we did not run the greeting, so let's do greeting of Mr. Brown. Okay, so let's actually take out this one. So print welcome Mr. Brown. It's our pleasure to see you. So right here, if we repeat one more time, and we say greeting, Miss Lin. Then the output will be welcome Mr. Brown. It is our pleasure to see you. Space. Welcome Miss Lin. It is our pleasure to see you. So the same function repeat 2 times with different name. Then we call it a parameter. A parameter is something that you want to parameterize your function. So your function can be reused with different parameter. And this function do not have the return value. So we call it, sometimes we call it this kind of function as a procedure. Okay, or sometimes we call it a function without return value. Okay, this is how we build a function, custom function. So x equals 5, print hello and print lyrics. Okay, so you print yo and x plus equals 2 and print x. So here you will print hello first and then define a function but did not run it and then print yo. So yo will be printed. Then print s from 5 update to 7, so you print 7. So hello yo 7. But the definition of the function right here did not have any effect. It said that you run the print lyrics, then you will be printing these 2 parts. So function definition and the function call, or we call it use of the function, is totally 2 different things. Definition of the function just define the function, but we did not call it. You did not invoke it. We did not use the code. It will be put into use only when you invoke it or call it. So right here, if we have if x equals 5, print hello, define the functions, and then print yo, and then print lyrics. Now, this time you print hello first, then print yo, then print the lyrics, then print x. So this has the function definition and the function call. Parameter. Parameter is the independent variable that we pass into the function. So right in this example right here, we pass a string to the maximum function, and maximum function will find the letter with the highest ASCII code. And in this case, it will be the lowercase w. So lowercase w will be saved in the variable big. So here we have a greet function with language. Okay, so if language equals ES, then we print hola. I think ES is Espanol, is Spanish. And then language equals FR, French. Then you print bonjour. Else you print hello. Okay, so you come with different language, you will print different way of greeting. So this is a parameterized function. A parameter is a variable which we use in a function definition. It is a handle that allows the code in the function to access the arguments. So sometimes we call it arguments, sometimes we call it parameters, sometimes we call it independent variable. They are all the same thing. They are all the input variable of your functions. Return value. Return value is the output function, output value. So if we have the greet function and return hello, then hello will be returned. So here, if we print the greet, then the return value hello string will be returned. So this one will print hello green, and this one will print hello Sherry. Okay, so right here, fruitful function is one that produces a result. So this one is a function that comes with return. We sometimes call it fruitful function. So putting things together, we can define a maximum function and then find a maximum. Okay. This is function definition, and the parameter is IMP. Okay. And then this is function call. You call this function and then get a return value back to it. Okay, you can also pass multiple parameter or arguments, such as this one, 18.2. You add A and B together and return the 18 value back. Okay. So when you add 2 for 3, 5, you return 8 and print 8. It's called multiple parameter. Void function, we also call non-fruitful function, and you will return nothing. But sometimes if you check the return value, it really will return a non-object. So this is additional idea, knowledge. We'll cover it later when we teach more advanced Python. So function, okay, so function is, you can always put your whole program without function, but if you want to make your program more readable, organize your code into paragraphs, capture a complete thought and name it. That is a better idea to simplify your program and make your program more readable. And do not repeat yourself, make it works once and reuse it. So reusable code is also very important. That will save your time for development of the program. And sometimes people make a big library of common stuff, and that you can use it over and over again. Now, let's look at another type of the program structure, loops. Loop is basically for repetition. If you have some section of the program you would like to run it many times, you need to use loop. So right here, we have n equals 5, while n greater than 0, print n, and then n decrease by 1. So basically, you need initialize to n to be 5, and then you print n once. So print out 5, and then print out 4, print out 3, okay, until this condition not met. When the condition not met, n greater than 0 have the inverse of it. It should be n less than equal to 0. So basically, when you get out of the loop, n should be 0. So basically, this one totally run for 5 times. And then it will print 5, 4, 3, 2, 1. This is a typical while loop. This is repeated the step. So this one, let's actually look at put into the program. Let me bring up the idle. Okay, let me create a new program. So sometimes, for example, I would like to do this. Okay, I would like to do print welcome to Java. Okay. I'm sorry, let's use welcome to Python. Okay. So for example, you would like to do this one, print this one for 10 times. So you may have to do this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then let's actually save it. But it doesn't make sense, right? Because you write the code just to do the same thing over and over again. And you actually waste a lot of code for doing it. Okay, let me call it welcome underline loop .py. So that's wrong. So it's a print of welcome to Python 10 times. But if I want to do this for 300 times, then you need to copy this another 30 times. So it really doesn't make sense to write this kind of a code, okay? And it also is very buggy and also not readable. So we will do this. We will do this one for 10 times. So let's use a counter, n equals 10. And while n less than 10, we do this. Okay? And every time n increased by 1. So let's do this. Let's do print. Okay. Okay. So let's run this one. This n, let's start it with 0. Okay. I'm sorry. Let's say one more time. So you print the welcome to Python 10 times, and then program stop. So right here, if I change it to 300, and you run for 300 times of the welcome to Python. Okay, and then program stop. So basically, such a program is more readable and more controllable compared to the one that we do print welcome to Python many, many times. But here, if you forget to put this n increase, then n always stay with 0. In that case, we call it infinite loop. So infinite loop happen when you forget to change the loop counter. and then you will continue to print it forever. Or sometimes this n equals 0 and n greater than 0, you do something. This one you never get into the loop. So sometimes you go into a infinite loop. Now this one, you never get off the loop. Keep going, keep going, keep going. Or you have a loop that actually you never enter it, bypass and never enter it. So either it's a zero loop, never happen, or an infinite loop. You need to be careful whether your program will enter into the loop successful. So that depends on your initial condition for the loop counter n. Okay. So next one, input loop. What is input loop? Let me create another one. Let's call it another name called, let's save us. It is called input loop, but I'm going to change it to call it REPL loop, okay, repeat loop. Okay, so it's a read, evaluate, print, and then loop, okay? So let's do this, let's have a number, okay? This one called n equals integer, convert from input string. Okay. So while n is positive, and this is the evaluation, okay? Then we actually add this n to a sum s. So we enter the number and we print it. And then we add that number to sum. And at the same time, we will read in the n one more time. Okay, so let's look at this structure. You do read to read the first number. Okay, and then you evaluate the number, whether it's within the range or not, whether it's a positive or not. And then you print it and you do some processing over here. And then you read it one more time to get a new number. It is negative, we don't do it. Okay, and right here we will do this, we will do print. So this program will take many numbers and calculate its sum. And that's print. Program terminated. Okay, let's run it. So enter integer 1. Okay, something wrong. Okay, something wrong. So you get a 1. You enter an integer, you get a 1, and n greater equal 0. Something wrong. Okay, let's look at the description. So it said that in line 6, enter an integer, invalid integer. Okay, something wrong. I enter a 1, but it doesn't take it. Okay. So let me run it one more time to make sure what's going on. Okay. I may have extra space or something. So right here, let me enter 1. Okay, and 2, 3, 4, 5. And then I will get out. So let's use a minus 99. So the program terminated. The sum is 15. So this is the so-called input loop. Okay, and I changed the name to reprint loop. So read, evaluate, print loop. So you can take as many number as possible and you will terminate the loop with a negative number. So this one actually is called a input loop. So next one, break label. Break label is very important to this kind of a loop. So let's look at another example. So here, let me introduce another loop called for loop. Okay, so we introduce n equals 0, and while n greater than less than 10, then print here welcome to Python. So this same program can be written in another way. Let's put n equals 0 again, and then do for loop. Or actually, okay, here you don't use n. So for your n in a list of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is called for loop. So this one n starting from 0, n up to 10, but not actually not equal 10. If equal 10, you break. Okay. And this one, it actually is take one sample at a time. Okay, that's actually also do print welcome to Python. So this is two loops. I'm going to prove it. They are identical. But this one, I'm going to put an exclamation mark there. And in between, let's put two print statements to separate them. So let me save us. Okay, let me save it as a for loop number 1. Okay. And that's wrong. So both print out 10 times. One is using the while loop. The other one we use for each loop, for each n number in the list 0 to 9. Okay. So you also run this loop for 10 times. It's similar to the while loop. So now let's try another one. You can also use a while n in range of 0 to 10. This one, the range function will generate a tuple with the value of 0 to 9, but it's a tuple. So every time you still take one number out of the range function and run it. So let me actually run this Python, the same thing. But here, let me put the 3 exclamation mark. Okay, so let's do run. Okay, so all 3 loop print out that welcome to Python 10 times. Now, let's save this one to another file. Let's call it for loop number 2. Okay, this time I'm not going to use any other loop. I'm going to focus on break label. So here I'm going to print this. Okay, loop n colon. Okay. Okay, so this one, you will do this 10 times. So starting from loop 0, welcome to Python, and the end of loop, okay, everything like that, okay? So now I'm going to add one more statement over here. It's called end of program. So this is the typical way of running the loop for 10 times, nothing special. Okay, now if right here I say if n equals 3, continue. So this continue will actually bypass the rest of the iteration. To 3. Okay, let's look at the result. Now let me change it to 5 to have fewer loops. So basically you run loop 0, end of loop 1, end of loop, and then you run loop 2, end of loop 3, you print loop 3, and then bypass the rest of the iteration using when you hit this line, and continue or escape everything after it for that iteration. Okay, so this is for loop number 2. Let's just save this one to number 3. So right here, let me change it to break. So break means different things. Not bypass the rest of the iteration, is actually breaking the loop completely. So whatever your loop is going on will be stopped. So loop 0, finish. Loop 1, finish. Loop 2, finish. Loop 3, bypass. And then go to the end of the program. So the rest of the loop iteration number 3 and 4 will be bypassed. That's called break label. So we introduce 2 break label. Continue to break iteration, and then break to break the whole loop. Next one, let's look at Tiffany loop. So Tiffany loop is a loop that actually you know how many run it will go. That's called Tiffany loop. Okay, so for example, you have for I in this list, and you print out every number. This will be a different loop because you are going to run it for 5 times. I equals 5, then I equals 4, I equals 3, I equals 2, and I equals 1. Totally you will run 5 times. Okay, so here we have a friend Joseph, Glenn, and Sally. So for friend in friend S. Okay, we will print a Happy New Year for them. So this is a different loop. It's a different because it has keep the same fixed number of the iterations. This is a different loop. Okay. Okay. And indefinite loop. Okay. So who is indefinite loop? The sum loop. This one is an indefinite loop because how many run it will go, we don't know until a negative number happens. It can be 0 time, can be 1 time. Okay. Let's go back to the loop. So next one is loop application. There are many loop application we can look at, but right here, let's look at the control loop, index loop, and statistic loop, okay, and some other loop. Let's create a loop. Let's create a loop function. This one, let me save it as loop apps py. Okay, so first one, that's actually taking the sum. If I have a list of 1, 2, 3, 4, 5, I want to take a sum. So sum equals 0 for element in A, okay, and then S plus equals element. You get a sum. Okay, this one you get a sum. Okay, now maximum. So maximum, we actually get the maximum value initially with A0. A0 is the first element, we get 1, okay, and we consider it's a maximum. So for every element in the list, if the element greater than the maximum will be equal to the element, okay? And at the very end, we print out the maximum will be equal n. Okay, that's the maximum. Now let's look at minimum. Minimum like m equals a0, same thing. We can pretty much copy the loop over. And here, if the element less than m, we assign it. Then this one will find the minimum. Okay, so these are the statistic loop that we would like to describe. Okay, next one, index loop. Index loop means that you have some index and some data. So that's when we have the friends. Ariel, Brian, Carol, and Daniel. Okay, so again, we can use a photo or name in the friends and print them. This is regular for each loop. Let's look at the result. Okay, so you print every one. Now I can use for every index in the range of the length of the friends. So the length of the friends is 4. So this one will generate a number from 0 to 3, including 3. Then you can print the friends i's value and then change line. This will create the same result as the previous one. So, okay, I'm sorry. It's actually called IDX, not I. Okay. Let me try one more time. So this one's for each index, you print out the A's, I's index value. So they do the same thing. This one is for each element in friends. This one is for each index from the range of the length of the friends. So it's a number from 0 to the length of the friends minus 1. And you get every index number and then use that index to retrieve the string from the friends. So this one's called index loop. Okay. So next one, counting loop. Let's use actually a n equals integer of the input. So this one is the actually a repeat loop. Where n is positive, if n take modular by 2 equals 0, okay, we will say even increase by 1. Else odd increase by 1. And then we will read another number. And then at the end of the program, we'll print there are okay, so you input 1, 2, 3, 4, 5, and then minus 99. So there are 2 even number and 3 odd number. This is a counting loop. So we do counting loop, finish this. And sentinel loop, the minus 99 is a sentinel, okay? And input validation loop, we are not going to touch this one too hard. So next one, let's look at the histogram loop, okay? Let's create a new one. Okay. So I'm going to save as histogram. So let's assume I have some data. It actually is 1, 2, 3. Okay, the number can only be from 0 to 4. Okay. So let's create a histogram H equals 0 and then times 5. Okay, this one will create a list of 5 zeros. Okay, so index number is 0 to 4. So for every number in A, okay, actually the histogram of the element will be increased. So we use another for loop. So for number n in range 0 to 5, and not including 5, or totally 5 numbers from 0 to 4, we print n occurs h of the n times. This is a histogram. We use a for loop to collect how many occurrence of the element. So whenever element we see an element, then its corresponding histogram element will be increased by 1. So that has 0 for 3 times, 1 for 6 times, 2 for 5 times, 3 for 3 times, 4 for 4 times. So this is a histogram loop. So let's go through slices. So right here we have before and for since in the elements, and then we print it. So before, then we print 9, 41, 12, 3, 40, 74, and 15. This we also call it a traversal loop, because you visit every number, so we also call it traversal loop. Okay. And this one before -1. So basically before large is so far. Okay, you go through every number, and if the number greater than the large is so far, then we will print the large is so far and also the current number. So this one is a loop to find the maximum value. Eventually we got 74. A counting loop is keep counting. Okay, you will count the number of the occurrence. So you keep counting with a log +1. So at the end you have 6. That means these have 6 numbers. Summing loop, you will sum things together. Okay, we already teach you how to sum the loop. Similarly, you use accumulation, log as an accumulator. Every time you add the things to the log, and log eventually will get a sum. Average loop is that you get a sum and divide it by the number of the counters. You get the average number. Filtering is that you actually will use a Boolean condition. If it happens, then you print it. So here, greater than 20, you only have 41 and 74. Okay, so search using a Boolean variable. So if you found, you say it's true and print the value. If not, you print false. It's a Boolean value loop. Find the smallest value similar to the maximum value. If the number greater than the number so far, you keep the largest one. I'm sorry, this one is still largest one loop. Okay. A smallest one, you need to actually do less than. You get the smallest one. At least the smallest one. You got this. Okay. Okay, there's another operator using is or is not to validate whether two objects are the same or not. Okay, that actually, this one will go into the details. Okay, so that's it for today's talk. Wish you enjoy the chapter. Thank you. Bye now. Welcome to chapter 4, the last chapter of the brief Python course. In this chapter, we will cover string, tuple, and the list. Objective: study the built-in Python basic data structure, tuple, list, set. So we already covered the string, and let's look at these 4 different data structures. So string is a collection of the characters. So it uses double quote, or sometimes you use single quote. Both are valid expression of the string, and string is a collection of characters. The next one is tuple using parentheses, and then list use brackets. Set use curly braces. So what are the difference of these string, tuple, list, and set? Set is similar to the set in math. It is a collection of data, and it will not be repeating the data itself. It is just looking at whether some data is in the set, the membership of a set or not. List allow repeating, and this also can be modified. This can be inserted with new data, can append new data to it. So this can be modified and can grow and can shrink. Tuple is immutable, cannot be changed. So tuple will not shrink or grow. And then set is not repeating. These are the difference of these three data types. And string is only for the characters or letters or text message. So in this chapter, we will cover the remaining three data structure: tuple, list, and set. So Python data structure including string, list, set, tuple, and dictionary. And dictionary and string is not covered in this chapter. String, we already covered it in chapter 2. And dictionary is a more advanced topic. We will cover it in more advanced courses. So right here, we only cover tuple, list, and set. Tuple. So tuple is a data collection of some data, and basically it is immutable. You cannot make the tuple longer or shorter. So it is a fixed size data, and also you cannot change the data content. And it is enclosed in parentheses. So sometimes you use 1 and 2 tuple. A tuple with single element must have the comma inside. So if you have a tuple with a single element, you need to finish with a comma. Don't write it as 12 parentheses. This is not a tuple. So must write 12 comma. This is a single element tuple. Okay, so right here you can assign 1, 1, 2, 2, 3, 3 as my tuple, and its first element is 0. Index 0, it is 11. So the indexing scheme is similar to the string scheme. -1 means this one. If your total length is actually 3, this one would be 3 minus 1. It actually the index is 2. And you can use negative indexing for it. And slicing is also allowed. So 0, 1 means a tuple starting from the first element and not including the second element. So you got a tuple of 11, one element only. So a single list, single data list, or single data tuple is different from a number. These are different. This is a single number. This one is a single numbered tuple. These two are different. So if you use the parentheses and 11, that means this is a number and you will evaluate it as a number 11. So tuples are immutable, so you cannot change the data. You cannot, this one means that you originally have 1, 1, 2, 2, 3, 3. And then you add a 4, 4 and create a new tuple, not the original one. And then assign back to the original one. So for example, you already have the 1, 1, 2, 2, 3, 3, and this my tuple is pointing to it. And then you create a new one with 11, 22, 33, 44, and your my tuple pointing to here, and then we'll remove the link to the original data. So it is immutable, but you can use the slicing or indexing scheme to create new tuples, but not replacing any data in the original one. So if you plus equal 55, you are not going to add a new member to the tuple. It is not concatenation or appending data because your tuple is not changeable or mutable. It's immutable. So you can apply sorting algorithm to it, but because the data cannot be changed, so your A tuple does sort. This is a destructive sorting on the A tuple. It is not applicable. And if you use the sorted, that will create a new sorted tuple that actually is fine. But here, one thing is wrong. Here must be parentheses. It's actually a tuple. I'm sorry. The output is a list, so it will create a bracket 1, 1, 2, 2, 3, 3. So your input is a tuple. Output is a list. When you use the sorted algorithm, if you use the sort function, that actually is destructive, and tuple doesn't have that function. So the length of the tuple is using length function, LEN function. And you check 44 in A tuple, this is checking the membership. It is not. And if you create I for I in A tuple, that is a comprehension list. So this one, you will get every I in A tuple and create a list for it. So A list equals 1, 1, 2, 2, 3, 3. That is a list. And if you do I for I in A list, this doesn't work. There's no comprehension tuple. There's only comprehension list. There's no comprehension tuple. Converting sequence into tuples, if you have 1, 1, 2, 2, 3, 3, that is a list, and you use tuple A list, that will convert the list to a tuple. And you can also convert a string to a tuple. And string is a collection of characters, so the new tuple would be a tuple of characters. So tuple, you will also have the length, maximum function, minimum function, sum function, any function, all function, sorted function, tuple. This is similar to the string list. They all have these different functions. Second data structure we will look at is the list. And this is different from tuple. This can be modified, can be inserted with data, can grow and can shrink. So this is a collection of data that allow to put many values in a single variable. A collection is nice because we carry out many of the values around in the one convenient package. So friends equal Joseph, Glenn, and Sarah. Carry on equals socks, shirt, and the perfume. This concatenate, you can use plus sign, this constant. So this constant using bracket that is a constant, and you can print it. So these constants are surrounded by square bracket, we call it brackets, and the element in the list are separated by comma. A list element can be any Python object, even another list. A list can be empty. Empty list, you actually use this bracket, and nothing inside. So here for I in 5, 4, 3, 2, 1. 5, 4, 3, 2, 1 is a list. And for loop, when you do for loop, every time you pick a data from the list and you print it. So it's a 5, 4, 3, 2, 1. When you finish, you print this breadth out. And this and the Tiffany look for these are best pair. They are good friends. So friends equal Joseph, Glenn, and Sally. You can say for each friend in friend S, and then you print Happy New Year for the friend, and you print out these. Okay. Looking inside the list, just like a string, you can use the index to figure out every single element, and you can also use it slicing to create sublist. These are mutable. That means that mute data, you can change the data inside the list. So if you assign a new value to the lotter 2, then this one will be changed to 28, and you print it, it will be like this. Okay, a string banana, strings a 0 location, you try to put a B there, it doesn't work because string is immutable. So string are immutable, we cannot change it, but we can convert it to a list, and then later convert it back to a string. And list is immutable, we can use that. So let's look at this one. If we want to change some data inside a string, then the original string is ABC. Let's assume this is S. And we can convert it to a list. Then this list, the content will become A, B, C, and then break. Now, if the list index number 1 location change to D, then that will create A, and then D, and then C. And then we can convert this list back to a string using double quote that join the ls. And this will create a string of A, D, C. So string convert to list using list function. List convert back to string. You use the empty string as a separator that join the list. So this tells you the conversion of the data types. How long is the list? You can use len function that will tell you how long the list and how many elements in the list. So this has a append function that will append an object to the end of the list. Count function to count how many times a certain number occurred. Remove, you can remove all of the X element from it. Reverse, that would change the order of the list to the reverse order. Extend, you can actually put some list sequence into the list. Index, that would look at the lowest index for that X. Insert, you can insert some data to the X. Pop, you will pop out some data from the list. So this one, you can look at it like this. Let's assume that we originally have a data of 1, 2, 3, index 0, 1, 2. Okay. So you can do append data to the end, such as append 4. Then you will add a new data there. You can do pop. If you do pop function, that will pop out the last element. You can also pop 1. Then you will remove the index 1's data. You can also do insert 1. So insert 1 with data 4. Then 4 will be put here. Something like that. Okay. So basically, these are different operations for list. Okay. So the range of the length, this whole thing will create a list of the indexes for the list. Okay, so here we have friends, and for friend in friends, we print Happy New Year for each of them. This one is for each element in the list. This one is for each index in the range function. Both will achieve the same thing. Now, we can use the plus sign to connect two lists together. It will generate a new list. So the new list we assign to C, that will be 1, 2, 3, 4, 5, 6. And you can also use the slicing to create a sublist. So here, T1, 3, 3 not included. So starting from 1, 2, 3, 3 not included. So it will be 41 and 12. Next one. This one is actually column 4 is starting from 0 and up to 4. So it will be 0, 1, 2, 3, 4, 4 not included. So it will generate 9, 41, 12, and 3. Next one, 3 to the end, 0, 1, 2, 3 to the end. So you get 3, 74, and 15. This is a column only. That means that starting from 0, ending at the end, that actually is the length of the tuple. I'm sorry, list. So it will be the whole thing. This method is to convert some data back to list. Building a list from scratch, you can create a new list using the list function and then append some data to it, one by one. And sum is a list, and you can check the membership using in operator. In is an operator. Your return value of true and false. These are in order. You can use that sort function. Again, this is destructive sorting. So friend after sorting will be changed. And if you don't want it to be changed, you can use the sorting function. And sorting function will not be changing the order of the data. Instead, you create a new list. You create a new list. Okay, so there are some built-in functions such as length, measure length of the list, maximum sum. Okay, this view scene is similar to the table that we see a moment ago for the tuple. Similar, okay. So right here, we have two algorithms to achieve the same thing. Okay, one is using append function and then using sum function. One is you calculate the total separately. Either way work. A string and list you can convert back and forth. You can actually split a string using that split function. And that would be each word is split by space. That will create 3 words. We call it tokens. Sometimes, and then you can use, and then the start would be a list. You can print them one by one. Okay, here we will have an example. When you do not specify a delimiter, you do not specify a delimiter on the string on the split function. A space will be used. Multiple spaces are treated like one delimiters. You can specify what delimiter character to use in the splitting. What would be the separator, such as using semicolon or comma. sometimes comma is very popular in this splitter because a comma is used in comma separated value files. Okay, so right here we have this file. Okay, so we actually have a text file, and then we find every line, and then we actually strip it, and then look at from. Okay, so from, you will see the from. Okay, that's a message, and then you split it. You just separate it by these. Okay, and then word. Okay, word 2, that would be this Saturday. Okay, and if it's Friday, it will be Friday. Okay. Okay, this is a technique to split the data from a string to a list of the strings. And double split patterns. This one, your line split, and you find the number 1. That would be your email address. Okay. And this email address can be separated by, again, okay, I'm sorry, this is a line you separated into word, and this one is the word 1. Okay. And you can separate it by sign. Then your username and domain name will be separated. Okay, similarly. Now we are going to talk about the set. Set is a collection of data, and in a set, the member will not repeat. So set is being represented by using the curly braces. So you have 3 string, and it included in the curly braces. We call it a set. So there are 3 members in this set. So if you have only one data in a set, we call it a singleton. So can only contain unique elements, so no duplication. Duplicate data will be eliminated. So this is actually a good feature. So for example, if you have a list, your list has the data of 1, 2, 3, 1, 2. Then so this is list, this one. So you convert it to set. Then this set will become 1, 2, 3. I'm sorry, this curly braces. And then you can convert it back to list. And you become a list of 1, 2, 3. In that way, you remove those duplicated items. So this is the feature of the set. So C set equals 1, 1, 2, 2, 3, 3. Okay, and when you print it, it will be 1, 1, 2, 2 because the duplicated pattern will be removed. So A set equals 1, 1, 2, 2, 3, 3. B set equals A set. Okay, and then A set equals A set or, okay, this one called union. So A set union to 5, 5, it will become 3, 3, 3, 1, 1, 2, 2, 5, 5, 4 member. Single bar, we call it union. Okay, we have a set that is, set have no order. So here's my set is apple, banana, and orange, and print my set. Okay. If you do my set 0, it wouldn't work because set does not have order. You want to access a single element, you change it to list or tuple. So we have a 1, 1, 2, 2, 3, 3, 2, 2, 4, 4. You convert it to a set, then 2, 2 will be removed. So only 4 elements remain. That's 1, 1, 2, 2, 3, 3, 4, 4. And you can plus 5, 5. Plus doesn't work. There's no concatenation. You can use union for it. No plus sign. So the len function is to see the length x in S. That would be checking element whether it's in the set or not. X not in set, make sure it's not in the set. So S is a subset of T. You can use S set less than equal T. S is a superset of the T. You will use a greater equal to. Union use bar. Intersect use S sign. Difference use minus. The inclusive or the symmetric differences that you actually use S cap T. So S cap T means that you will just keep the member in one set but not in both. S the copy that will create a new copy of the set. So union of the two sets, you will combine two sets together. Intersect, you will only create a set that actually have a common element in both A set and B set. Okay, difference of two sets, A minus B, that means you will collect the members that from A but not in B. So it's S set minus the A set element that also in B set. Okay, so A, B two set contain all elements that are either in A, okay, symmetric elements. So you only collect the data that's in A but not in B, or in B but not in A. That's called symmetric difference of the two sets, or we use cap sign. Okay, this one, okay. So original we have A set 1, 1, 2, 2, 3, 3, B set 1, 1, 2, 2, 1, 2, 2, 3, 3, 3, and then two set intersection, the common element only 33. Okay, A set minus B set, so that member in A set but not in B set. So 3, 3 reduplicate, this must be removed. So it will be 1, 1, 2, 2. And then if you look at the symmetric difference, something in A set but not in B set, that would be 1, 1, 2, 2. Something in B set but not in A set, that would be 1, 2, and 2, 3. So the union of them would be 1, 1, 2, 2, 1, 2, 1, 2, 3. A symmetric difference. Okay, Python's dictionary similar to JSON's JavaScript, JSON's object, and Python's list similar to JSON's array, JavaScript's array. Python's string similar to JSON's string. Python's number, integer, or long, are similar to the number integer in JSON. Float similar to the real number in JSON. True and false, they are also the same, except that the JSON use lowercase. Okay, these are the different data structures in Python, and we go over these basic types. So we may have some demonstration for these different data types. Now let's look at examples. First, let's look at the tuples examples. I'm going to save this file to the directory. So right here, I'm going to create a new folder called BP4 for the chapter 4. Okay, first one, I'm going to save this one as a tuple.py. So a tuple is a collection of data. Usually can be used for a data point, such as a point 1 and 3. Okay, you can have a second point, 4 and 5. Okay, and then you can print them. Okay, so 2 points got printed. But we can calculate the distance for these 2 points, so we can define a function for these 2 points, P1 and P2, and dx data x. Okay, that has a 2 points. So it's just like you have 2 points, P1 and P2. So this one's S1, Y1. This one's S2, Y2. So the distance is delta x, is delta y. Okay. So delta x equals actually x2 minus x1. Delta y equals y2 minus y1. And then this distance will be square root of delta x squared plus delta y squared. Okay, that's the formula. So we can do that. So dx equals P2. P2 is 0 minus P1's first tuple. Okay, this is dx. And because you are going to take the dx squared, so positive, negative, it doesn't matter. Okay, that's dy, and then you will return, okay, dx square plus dy square and take square root of it. This one you need to import. Actually, this should do from mesh, import sqrt. Okay, and then you can say d equals distance for P1 and P2. Okay, so this is a typical way of using the tuple to represent data points, and usually it's good to save the coordinate of the points, and then you can do some processing of it. That's the good part about the tuple. And tuple can be used for multi-dimensional data as well. And right here, we are using the 2-dimensional data as an example. And this is the typical way of using the tuple. Now let's look at tuple 2. Conversion of the tuple data and the string. So right here, you can have a string that equals A, B, C, D, E, F, G. Okay, you can convert it to tuple using tuple of the S, and you run it. Okay, this one, let me see. This one, let me put it over here. Let me move previous file should be put here. So this one, let's call it tuple 2. With the BP4, okay. So save it. I didn't print anything, so right here, let's do print tuple. Okay, so you convert the data to a tuple, but now tuple cannot be modified. Okay, so if you do tuples 2 equal G, that won't work. Okay, that won't work. You run it, you will be in trouble. It's immutable, so you cannot do that. So you may want to convert it to a list. So L T, okay, equals list of the T, okay, and then you print LT. Okay, so this time it converts the tuple to a list of data. So these are the relationship. You can have a string. You can convert it to tuple. Or you convert it to a list. This using the list function, this one using the tuple function. Okay, vice versa, here to here the same, using tuple function, using list function. Now, if we want to convert back from tuple to this or from this to this, okay? Let's see how we can do it. So from the list back to string, you can do SL equals empty string that join list, and you print SL. So you put now A, B, C, D, E, F, G. But if here you actually put a plus sign, that means you connect the string using the plus sign, you will get this. Okay, that's the join function. It's a join function. So this show you the conversion between the string and tuple and the list. Okay. Next one. Let's look at the list operation. So this file, let's call it list 1. Okay. So there are a few ways to create a list. Let's do list 1 equals 1, 2, 3, 4. And you print this one. The first way is creating list by examples. Second, you can do this. You can do this 2 equals T or T in range 4. This one create a list of 0, 1, 2, 3. Because you are creating a range list, and every element of it, you make it on the list 2. So this one is called comprehension list. Third one, you can create a list by using the list function. At this moment, the list 3 should be empty. So let's print it up to here. Okay, so that's what it is. Now, after that, you can do list 3 that append by list 3 that append 6. Okay, so you can use append to create the list. This is a third way we can create a list. Okay, so these are different way of creating list. Okay, this is a list number 1. Now let's look at list number 2. The operation about the list. Let's assume that we originally have a list of 2, 4, 6, 8, 10, the even number under 10. Okay, now let's look at the different operations. So A, that append 12. So let's print A first. And after this, let's print A again. And this one, let's call it list number 2. Okay, so you append the 12 after it. Next one, if you want to pop the last element, okay, so this one is, let me put some note to it. Okay, this one we pop out the last element. So the 12 can pop out. That's a single pop, but you can pop any specific location, such as then the index 2 location will be pop out. You can save it to a variable. Okay, so this one you remove the 6. So 6 got pop out, and then the insert 2 location got pop out. Now you can also insert it back. So let's do this one. A dot insert 2 again. Put an R back. Okay, and then we print it one more time. Okay, so it becomes like this. Now we may have a B list that equals 1, 3. So to list we use plus sign, then we concatenate the 2 lists together to create a new list. Okay, so two lists are connected together. These are the basic operations of the list. Okay, these are the basic operation list. The slicing portion is the same as the string, so we don't emphasize on it. Okay, we don't emphasize on it. Next one, let's look at the set. So set, the main purpose is to remove the duplicated item. So let's have the A equals okay, something like this. And then let's do SA equals a set of A. And let's print SA. Okay, so the set becomes this, okay? Okay, I'm creating now different files. So this is the set A, okay? At this moment, the set A is 1, 2, 3, 4. Okay, this is 1, 2, 3, 4. This moment. Let me copy it back to my file here. Okay, and then we have a set B. Okay, then we print our set B. So that would be 2 and 4. Okay, next one. Let me put one more thing there. Let's also put a 5 there. Now, next one, let's look at the union. So UAB equals SA union with SB. Okay. Like that, okay. And then we may have intersection of A and B. Okay, this will create intersection of A and B. Okay, next one. The intersection is only 2 and 4. Next one, we can add an element to A. Okay, so SA plus equals plus equals 5. This is not okay. Okay, you cannot use plus sign for an element. The plus sign is actually is connecting together. So you make a set of these. Okay, you cannot use plus equals. So let's do this. Let's do S equals SA plus another set. Okay. So these are joining two sets together. I'm sorry, you use the union. Okay. Now add an element to it. Okay, add an element to it. Okay, so these are the concepts. Let me look at the set one more time. So these are the operation for it. Okay. Okay, that's about it for this chapter. We give you a short demonstration of how to create these different data collections and make them into use. Okay. Thank you. Bye now.